All right, welcome to the AWS Serverless and Containers workshop featuring ClearScale. We're going to give just a couple of minutes for people to pour in, but you should notice that there are a couple of quick polls that are available while we wait. So if you'd like to take a minute to answer these, we'll get started here very shortly. Those two polls are: where are you in your serverless and containers adoption? Would love to know if you're currently using or if it's something that you're just currently exploring. And then this workshop is typically designed for level 200, 300 attendee professionals. But certainly if you're level 100 or 400, we are thrilled to have you as well. If you're 400, you might be teaching next time. So be warned. But we'll give just another minute for people to pour in, and then we will get started. Thanks, everybody. All right, everybody. Welcome to the AWS Serverless and Containers workshop featuring ClearScale. I am Jay Martin, essentially your host and air traffic control for the next few hours. As you likely already know, this interactive lab is going to illustrate how we deploy and scale cloud-native applications faster and more efficiently by migrating from Monolith to microservices. This is absolutely interactive, so please utilize the chat function to post questions, ask for support, or simply acknowledge the great information from our team. Speaking of our team, we've brought in a wonderful group of experts standing by to assist at all times, so please don't hesitate to reach out. We've got a number of solutions architects who will be tasked with presenting today, including Ramesh Chittarala, Sabo Parmeswaran, Todd Schaefer, Alan Litz, and Robert Bryant. But behind the scenes, we also have a huge support staff. So please, again, questions can't be too small, too big. If you do need help during the labs and would like to go into a private conversation so you can work through a couple of challenges that you're having, we can do that as well. But before we get started, I'd like to pass it over to Robert from ClearScale. Robert, if you could give a quick introduction of yourself and your role on the ClearScale team.
Hi, my name is Robert Bryant. I am a solutions architect here at ClearScale. I've been here for about 3 years. I work primarily on migrations and security projects, or both pre-sale and project-based work. ClearScale's been around since 2011. We were born in the cloud. We're an all-in AWS partner, meaning that we only work with AWS and not other cloud partners. We've been a premier consulting partner of AWS since 2015 and have completed over 850 projects or so. All of our ClearScale engineers, architects, developers all hold AWS certifications. Last count I saw, we had well over 200 certifications in-house. And ClearScale also holds 11 AWS competencies, and we'll talk about these here a little bit later also. But those are for migration, DevOps, Microsoft, healthcare, education, data and analytics, SaaS, nonprofit, IoT, mobile, and machine learning. So those are areas where AWS has recognized that we have expertise in, and we have proven that with projects and skills assessments. Back over to you. Jay? Or Ramesh, I guess.
Hey, thanks, Robert. Hi, I'm Ramesh Sridharwala. I'm a solutions architect here at AWS, and I work with customers in the SMB segment in the central region, helping them achieve their desired business outcomes on AWS. I'm passionate about serverless and containers, and modernization is near and dear to my heart. So, looking forward to a great interactive session with you all today.
Excellent. Thank you, Ramesh. All right. Well, today we have a three-pronged approach to our workshop. We're going to start with a presentation for about the first hour, which is going to include some fantastic real-world case studies discussing the implementation of containers and serverless. And then we're going to dive into the world of unicorns by way of the Unishop, a fictional store where we'll be moving to a microservices-based architecture. So without further delay, I know everybody wants to start getting into the presentations and get into the labs. So Ramesh, I will pass it back over to you for the start of today's presentation. Thanks, everybody.
Thanks, Jay. Hi, everyone. Thanks for joining today's session. We'll be discussing how to think about modern compute as we move to the cloud today. Containers and serverless are fast becoming the standard for how customers are developing with cloud native principles. But there still are some considerations to be had on what is right for you. And today we look forward to sharing some thoughts, suggestions, and examples. Hopefully, you're able to take these learnings with you as you think through your own modernization efforts. And here's a quick look at the agenda. We'll discuss the need for modernization and evolution of architectures. We'll explore the computing options you have when looking at cloud native architectures. We will then go deep into containers and serverless, and then look at how some of our customers are using serverless and containers for their modernization goals. When we asked our most successful customers, what do they want from us? Here's what we heard. They're looking for ways to enable quick innovation to be able to compete in a global market. They want their teams to deliver products to customers as fast as possible. They want their applications and infrastructure to be reliable, highly available, and scalable. They want the highest security and isolation, and they want all of this with a lower cost of ownership. COVID-19 has accelerated the need for digital transformation and business agility. Organizations that embraced cloud services proved more responsive and were able to continue operating remotely and serving their customers, demonstrating agility, scalability, and speed. And what is the biggest barrier to innovation? It's the lack of time spent on what matters. CIOs want development teams to focus on innovation and move with speed. But today, most of the time is spent on operations and maintenance. IDC analyzed a large number of organizations over a 5-year span that utilized our serverless platform, and they found some fascinating results. What's most compelling is how quickly you see that payback. 9 months to get a payback is rarely seen in our industry. We expected the faster deployments and higher productivity because of the automation that Lambda and our serverless portfolio provides. The lower cost of operations comes primarily from not spending time on reactive scaling, patching, or other infrastructure issues. Now that you're aware about the business motivations for modernization, let's explore the strategies and choices customers have on AWS. Let's look at these choices through the lens of the shared responsibility model. While AWS is responsible for protecting the infrastructure that runs all of the services offered in the AWS cloud, customer responsibility will be determined by the service that they select. As customers move their workloads to the cloud, we provide them the choice to control as much of the infrastructure as they want. By choosing services that you see here on the left, you retain most of the operational responsibility. As you move towards adopting services on the right, you start offloading more of the undifferentiated heavy lifting over to AWS. And on the far right are the services where we abstract away all the complexity for you. For example, customers who choose to deploy an Amazon EC2 instance, which is the virtual machine, either for compute or self-managing database or Hadoop are still responsible for management of the guest operating system, including updates, security patches, and any application software they choose to install on those instances. In the middle, you see some of our managed services, such as Amazon MQ, which provides a managed message broker service. And the management aspect takes care of the operating of your message broker, including setup, monitoring, maintenance, and provisioning the underlying infrastructure for high availability and durability. Similarly, Amazon RDS, the relational database service, manages the work involved in setting up a relational database, from provisioning the infrastructure capacity to installing the database software, performing backups, and patching the database software. With optional multi-AZ deployments, RDS also manages synchronous data replication across availability zones with automatic failover. And services on the right provide the highest level of abstraction, such as AWS Lambda, DynamoDB, S3. AWS operates the infrastructure layer, the operating system, and platforms, while customers access the endpoints to store and retrieve data. Customers are responsible for managing their data, including encryption options, and using security tools to apply the appropriate permissions. Our goal is to provide you more choice and also to provide you a path to modernize so that you're responsible for less and we manage more of your infrastructure. This will free up your time to focus on improving your business outcomes. Gartner Research positions AWS in the leaders quadrant of the 2021 Magic Quadrant for Cloud Infrastructure and Platform Services, primarily because the infrastructure resources are complemented by integrated platform services. One of the important choices you will make in your modernization journey will be around application architecture and compute strategy. So let's explore the options you have around these. Here's how application architectures have evolved to keep up with the demands of the modern business and application landscape. Traditional architectures have been dominated by the concept of monolithic applications before they evolved into microservices-based architectures. With a monolithic application, you're often limited to a single technology stack for the entire app. Shared release pipeline causing friction at many points of the lifecycle, interdependencies on shared libraries, and even the smallest change causes the entire app to be rebuilt, retested, and redeployed. On the other hand, microservices-based architectures can be deployed independently, where each service owns its own data and is not tightly coupled to any part of the overall solution. This enables each service to scale on its own and set its own SLAs, which makes it easy to migrate the individual services to newer and better technology stacks because of the lower impact to the overall workload. Now, microservices existed before the cloud, but cloud allows to easily make use of them. Once you have identified the monolithic application that has a high business value with associated high cost, you can start thinking about breaking it apart into microservices. This was the same pattern that Amazon.com used when they were no longer able to scale their application. And in today's workshop, you will be guided through the process of moving from a monolithic architecture to a microservices-based architecture. We've seen a paradigm shift on compute. Not too long ago, and in some places even now, there are organizations who prefer to maintain their own data centers. Consequently, they're not able to leverage all the innovation that's happening in the cloud. They need to renew the hardware regularly to keep up with the pace and have an upfront capital expenditure before they can do any innovation. Then there is a good set of customers that are moving to the cloud and leveraging virtual machines. And the reasons why customers move to the cloud typically starts with cost, with pay per use pricing model, but we believe agility and innovation are the more important reasons. You can quickly spin up infrastructure for an experiment fearlessly and terminate it if it does not work out. This increases the amount of innovation that happens in your company. There is no need to do capacity planning ahead of time due to the elasticity cloud offers. You can quickly tap into all the innovation happening in the cloud, and you can leverage the global infrastructure to make your application available across the world. Third wave is of containers, which gives you a high degree of mobility. You're running something on-prem and want to keep those investments, yet be able to run in production in the cloud. Containers make it possible to package your applications and move them between different computing environments. It starts a lot more rapidly than the VMs, and you get a highly flexible tool chain. But you're still managing servers, updating the operating system, and patching it. Customers running containers who don't want to manage servers can choose AWS Fargate, which is a serverless compute engine. And then there is AWS Lambda, which is at the highest level of abstraction. With Lambda, you build your code and let AWS worry about the infrastructure. As a result, it enables customers to move the fastest. So, what are customers building with containers and Lambda? We see customers building a wide variety of applications, but there are a few common areas where they tend to see huge benefits. Automating basic IT tasks is a common place to start, for example, using Lambda functions to validate some configuration each time an EC2 instance is launched. Building data processing applications is also common. A lot of times, this will be the first big modern application for modern computing. And then, as experience with modern computing spreads, we start to see multiple teams will start building whole microservices based web and mobile applications. And finally, teams start to leverage these technologies in their most advanced applications as it applies to machine learning. It's important to note that there are no wrong choices here. In many of the most important ways, ECS, EKS, and Lambda give you the same benefits. All three services, Lambda, ECS, and EKS, are fully managed by AWS. All three services have deep integration with AWS automation and deployment services, networking, storage, security, observability, and the AWS ecosystem of partners. And all three services support a broad range of use cases and workloads. But there are some distinct differences and nuances that you need to be aware of as you come down this path. First, Lambda is event-oriented. This means that it sits idle, ready by your side until an event is triggered, and the system jumps into action. Once the event is triggered, resources are spun up and down to meet the need of the task at millisecond speed. There is no need to worry about the infrastructure provisioning or configuration, and you literally pay only for what you use. This means faster time to production with the lowest possible TCO. Containers, on the other hand, are compute-oriented. This means it has similar constructs to a physical server or a VM, but what makes it different is that it allows customers to turn monolithic applications into modular, portable, and composable services. By creating these bite-sized services and using container orchestration services like ECS and EKS, infrastructure becomes a lot easier to manage, and reliability and resiliency increases as you're removing single points of failure. Unlike serverless, containers still give you the options to define and pick your resources and types of services for your app. While you still only pay for what you use, a container is instance-based, while Lambda is request-based. And the reality is, most customers are using both containers and Lambda because rarely do customers have only one single need. Most of the time, the decision on compute isn't really an or, it's an and. And one of the best examples is T-Mobile. They built a serverless developer platform and they use Lambda for a lot of customer-facing apps, but they also use Kubernetes for their always-on applications. And the results speak for themselves. They grew both NPS and customer base with a strategy that enabled them to use the right tool for the job. Let's look at some of the ideas on when should you be selecting containers. So think about when you need to build stateful applications, when you need a daemon or a sidecar to run alongside your service, when you need kernel tuning support or support for Windows containers or legacy .NET, and when you're looking for hybrid scenarios or on-premises portability and container image portability with Docker runtime, and the ability to purchase different billing models, which could be on demand, reserved instances, or spot. One of our customers, Snap Inc., embarked upon a modernization journey, and they broke up their monolithic application by adopting Amazon EKS and ECR, and they now run over 2 million transactions per second and reduce the time it takes developers to launch new services by 77%. Containers represent the majority of all applications being built and deployed today. Two-thirds of the industry's containers are running on AWS because we have the broadest choice. Many customers simply like containers due to the portability and the rich ecosystem. Others have a strong open source preference that leads them to Kubernetes. And other customers have business requirements when it comes to managing infrastructure. And for these customers, ECS or EKS will fit the bill. And when you're thinking about containers, you also have the choice to think about where you want to run. Many have good reasons to run outside of AWS. These could be regulations, data gravity, or maybe you're just too busy to take on a migration project right now. We can meet you where you are, not just in the AWS cloud regions, but in local zones and wavelength on the edge, and in your data center with outposts, bringing our container services closer to more customers. AWS Outposts is a fully managed service that offers the same AWS infrastructure, services, and APIs to virtually any data center, co-location, or an on-prem facility for a truly consistent hybrid experience. AWS Local Zones are a type of infrastructure deployment that places compute, storage, database, and other select AWS services closer to large population in industry centers, and AWS Wavelength embeds AWS compute and storage services within 5G networks, providing mobile edge computing infrastructure for developing, deploying, and scaling ultra-low latency applications. And now ECS and EKS Anywhere allows customers to run and manage container workloads on customer managed infrastructure. ECS Anywhere allows customers to deploy native ECS tasks in any environment. And EKS Anywhere is the new deployment option for EKS that allows customers to create and operate Kubernetes clusters on customer managed infrastructure while being supported by AWS. Finally, you have options when it comes to your container orchestrator. Once customers have provisioned infrastructure, they'll need an orchestrator to provision and manage their containers and containerized applications. The customers may have different preferences. If you want to go all in on AWS, ECS is a great option, simplifying many decisions with an opinionated set of automations. A video and analytics platform provider for coaches and athletes, one of our customers, quickly wanted to review game footage, and they used Amazon ECS to generate player tracking data with a simple but highly scalable pipeline. And they were able to adjust the cluster size to balance cost and processing time. And they had a machine learning process that used to take 5+ hours in batch mode, but now they are able to run in real time. On the other hand, if you want open source flexibility and to bring in a community of tools, EKS brings Kubernetes to AWS. A customer story is someone who built a technology platform to create a kid-safe digital entertainment, grew from 2 Kubernetes clusters to more than 20. This led to additional complexity, and to keep things simple and manageable, they switched to Amazon EKS, and this allowed customer to get the benefits from all the features of Kubernetes without the hassle of managing the clusters themselves. Now let's look at some of the ideas on when choosing serverless makes sense. Now, serverless fits numerous use cases, including IT automation, microservices, data processing. The general rule of thumb is if the workload is event-driven, stateless, and can be performed in under 15 minutes, it may be a good fit for serverless. So when you're thinking about a lightweight, application-focused stateless computing, when you want to focus on business logic and not IT operations, if you are trying to enable real-time data processing or serverless backends and reduce complexity for development and operations, serverless would be a great choice. One of our customers, a major UK charity company, went serverless on AWS, and they can now process up to 350 donations per second during peak broadcast moments while achieving a 93% cost reduction. Now, Lambda is ultimately an event-driven compute service. To understand Lambda, you need to understand what we mean when we say events. In the simplest terms, an event is a signal that a system state has changed. In most modern systems, these are represented as JSON messages that provide some set of facts about what changed, potentially what the current state of the system is, and what action needs to be taken. When we say serverless, we mean it's the removal of the undifferentiated heavy lifting, that is server operations. This is an important distinction for customers because it allows customers to focus on the building of the application rather than the management and scaling of the infrastructure to support the application. We feel strongly about the benefits of event-driven design because it can improve reliability and scalability. Now, events are asynchronous. You don't need to wait for a response to move on to the next step. This improves resilience and reduces dependencies. The tools of event-driven architectures are routers that abstract producers and consumers from each other. You can publish to the router and consume from it without knowledge of other producers or consumers. Event routers at AWS include EventBridge and SNS. Event stores act as buffers, holding on to events until the consumer is ready to use them. At AWS, SQS is our serverless event store or a queue, and Amazon MQ is another queue that uses standard APIs and protocols, including AMQP, MQTT, and WebSockets. Now, Lego builds with an event-driven design. Back in 2017, Lego had a monolith, but after a Black Friday sale crashed their entire system, they were looking for something that was more scalable. They began decoupling their backend and building an event-driven serverless application that they launched in 2019. The architecture you see here is a new hub and spoke design that makes a much simpler way to operate events rather than using point-to-point connections. We talked earlier about how integrations are essential to leverage Lambda. And here you can see how Lego uses EventBridge to act as a central event hub for Lambda functions. And you see various microservices here taking care of one aspect of the system. So it is possible to independently scale them without impacting the other services. Let's look at some of the new features which were recently launched. We heard from our customers that they wanted to invest in one set of tooling and training for the first part of their software lifecycle, the edit, build, test, and package phases, which is why we launched the ability to define and package Lambda functions using container images. Our goal here is very simple. We want customers to get the full benefit of their investment in container tooling for building and packaging software, while also getting the full benefit of Lambda's native service integrations, simple programming model, and pay-per-use billing. And the built-in automated scaling that is more than an order of magnitude faster than cold start scaling in container orchestration systems. Let's look at a decision tree that you could use in order to help guide which of these services would be the right fit for you, depending on the use case, the requirements that you might have, and the scenarios that you're trying to accomplish. So let's say you desire to have platform runtime management, and you also desire an on-prem portability and a hybrid architecture, which is a very common use case when customers are beginning to migrate and have existing investments in container tooling. And that's where EKS would make most sense. One customer use case, New Relic, they initially migrated their own Kubernetes clusters to run on EC2 instances initially in preparation for the eventual move to EKS. And since the move to EKS, New Relic was able to speed up their migration, and they're now able to ingest 90% of customer data on their EKS clusters. They're running dozens of EKS clusters, including 19,000 nodes and more than 150,000 pods, and with plans to triple these numbers over the next year. So that's a scenario where you're looking for platform runtime management and you're looking for hybrid or on-prem portability. Let's now look at Ecs Decision Chart, where if you are looking for, if you're not invested in Kubernetes, if you're not invested in an existing orchestration system, but let's say you still have an existing Docker and containerization tooling, that's where ECS makes it easy to migrate to AWS with your existing investments. And one of the customer studies, uh, case studies we have is Babel, who provides the world's best-selling language learning app. Their legacy platform relied on an old stack running on AWS OpsWorks, and while designing their modernization strategy, their main objective was to have a platform that scales their Docker containers with the least amount of effort and with the smallest number of changes in their environment. And they chose ECS on Fargate, and they also used Lambda in order to gain the benefits, which includes faster releases and rollback times, reduced maintenance times, and it allowed them to focus on building new features for learners. They went from deployment times from 25 to 30 minutes per OpsWorks cluster to almost instant deployments and rollbacks with AWS Lambda and ECS on AWS Fargate. And that's where Fargate, the way we talked about, it provides you a serverless compute engine. It's really if you like to adopt containers but you don't want to manage servers, then Fargate becomes a great choice. One of our customers, a firm in a highly regulated financial services industry, opted to use Fargate alongside ECS, and they were able to reduce their unit costs by 50%. Let's look at where Lambda would make most sense. We already looked at the general rule of thumb, stateless workload, event-driven, and less than 15 minutes of execution time. So one of our customers, who was a startup that enables users to buy bundled home and auto insurance online, they were looking for modernization options. And considering an event-driven architecture was the right fit for them, they went with modern technologies like Lambda and DynamoDB and AppSync, and they were able to keep their development costs low and uptime high. They were able to respond to the complexities inherent in traditional systems for buying home and auto insurance, and they were able to help the customers get the most of their money by eliminating intermediaries and utilizing serverless technologies. Let's look at some additional customer examples. Nielsen Marketing Cloud is a data management platform built from scratch. They get data in and process it to about 100 different ad networks, requiring about 25 billion events per day. And they use Lambda to process files and fan out data, all while maintaining quality, performance, and cost using a fully automated serverless pipeline. At the end of the pipeline, they also rate limit the number of files to their ad partners to ensure they don't overload their partner networks. And on a peak day, Nielsen achieves 55 terabytes of data, requiring 3,000 lambdas running concurrently. Let's look at some more success stories. Here you can see Quora and Vidsi are two examples of customers who are able to leverage our managed container services. With the EKS and ECS, a lot of the undifferentiated heavy lifting of managing a container environment can be left to AWS. Those that need a platform aligned with open source or cloud native computing foundation and have K8's expertise can leverage EKS. And for customers new to containers, we suggest using ECS and Fargate for the simplest and fastest way to get your first applications deployed with minimal operational overhead. And some more serverless success stories are Finra and Coca-Cola. Now, Lambda, the way we saw, is a platform for super fast innovation, enabling you to react to changing market and customer dynamics quickly. Finra took a legacy Hadoop cluster and was able to refactor into a Lambda data processing pipeline in just 3 months. And this unlocked their ability to scale while also decreasing their costs. Coca-Cola is a great example of how a serverless strategy enabled agility when they had to react quickly to the changes brought on by the COVID pandemic. They wanted to provide a touchless experience for their freestyle drink dispensers, and so built a new smartphone app that allows customers to order and pay for drinks without coming into contact with their vending machines. Because they built with Lambda, their team was able to focus on the application rather than the latency or scalability, since with Lambda, that's all built in. As a result, they built this new application in just 100 days. And now over 30,000 machines have the touchless capability. With that, hopefully we've given you enough business use cases and motivation to embark upon your modernization journey. Here are some resources. Here you can see the workshop link, which is what you'll be going through today, and some starter links for containers and serverless that can lead you to more modernization techniques.
Excellent. Thank you, Ramesh. And along with these resources, within the handout section, you can also find a download of today's presentation. Certainly, if you are interested in some of the upcoming ClearScale offers, those are available for download, as well as booking a meeting and some other fantastic links. I'm now going to pass it over to Robert so that he can give a brief overview of both Salvation Army and Savvy Money, two clients that we helped with their serverless and containers implementations as well. Robert, all yours.
Yeah, thanks, Jay. So these are two case studies that I'll discuss that ClearScale did some work for. The first one being Salvation Army. Everyone's heard of the Salvation Army. They've been around for more than 100 years. They created the Red Kettles back in the late 1800s to help children and families in need during the holiday season. In the past, the Red Kettles have collected cash donations, but recently the Salvation Army wanted to accept new forms of payment. They wanted to create and host a simple mobile donation application and website to accept credit cards, Google Pay or Google and Apple Pay. So the Salvation Army chose ClearScale to create this donation app, the infrastructure to run it, and the website and a backend to provide monitoring and other ongoing support. They had a really tight timeline as the app needed to be ready to roll out by November 5th, a few weeks before the holiday season. And this gave ClearScale a little over a month to design the architecture, then develop, deploy, and provide documentation for the app. So for the backend and website, ClearScale developed an event-driven serverless solution using Lambda S3, fronted by using CloudFront and API Gateway. So kind of that same technology that Ramesh was just talking about, created an event-driven solution. With this solution implemented, the Salvation Army's new mobile donation collection capability allowed donors to scan a QR code that was there at the Red Kettle. And that opened a website with a mobile app and allowed them to make a contribution through one of those several payment methods that I mentioned. The Salvation Army, well, that worked good that year. The next year, the Salvation Army decided to re-engage ClearScale to see how the two could partner again to enhance that cashless donor experience. The QR code method was not as smooth as they would like it to be, and so ClearScale proposed using NFC technology to enhance that user experience. ClearScale began piloting the NFC capability by confirming the ease and the value of the wireless bump to pay approach. And so now, thanks to that new NFC technology that ClearScale put in place, those who want to donate at the Salvation Army Red Kettles simply just bring their devices near the NFC tag at the Red Kettle to start that donation process. And so people are no longer fumbling with trying to take a picture of the QR code and trying to figure out how to do that. This bump to pay approach kind of streamlined that and made that user experience much more smooth. So that's an example of kind of the serverless event-driven approach that of a project we've done here recently. The next one here is a company. This is more of a containerized approach. So Savvy Money is a fintech company that provides integrated credit score and personal finance solutions to credit unions and banks. ClearScale had previously partnered with Savvy Money to design and build their AWS environment originally, but Savvy Money had seen amazing growth over the last 5 years, and the company's signed up more than 420 financial institutions and 34 different online and mobile banking platforms. And they also had expected growth to add another 10 to 12 institutions per month, and were likely to integrate with another 10 to 15 more platforms, banking platforms. And so they had a need for great scalability, and even working with a specific platform, multiple configurations of that same function were often required for their different tenants. And additional customers also meant an increase in the number of tenants sharing that same SaaS infrastructure and resources, requiring greater scalability to meet that demand. The more tenants they added, the more tenant native applications Savvy Money had to deal with, along with the platform customizations and requirements. So working with Savvy Money's team, ClearScale re-architected their multi-tenant SaaS platform. We made several improvements to the solution, including rebuilding the application to run on top of ECS. We also created a CMS site for to better manage the tenant isolation and the pooled infrastructure that's being used under the hood. We made several UI modernization updates. We put in place a new CI/CD process, added some monitoring enhancements. The new delivery pipeline is implemented through Docker container deployments to ECS using CloudFormation to multiple environments. The use of managed services in a multi-AZ configuration, such as Elasticache, load balancers, and ECS, ensures that the SaaS platforms has high availability. This new solution allowed Savvy Money to make production releases with minimal impact on application performance and no downtime, including when new tenants were added. The entire tenant build process can be tracked, which significantly improves the feedback cycle, allowing Savvy Money to quickly extend its customer base and drive more innovation. So that's another example in this one where it's more container-based of how ClearScale can help customers modernize and improve on their existing applications. Back to you, Jay.
Actually, before that,
I'm sorry. Yep.
Quickly go over the options would be great. Thanks.
I should probably go on. No. We have several map offerings, and if you're not familiar with the map program from AWS, it is a migration acceleration program that helps companies migrate to AWS. And there are three main phases of MAP. The first one being a migration readiness assessment. We often refer to it as MRA. It's a 1 to 2 day engagement where we look to identify any challenges you might have with migrating, identify any capability gaps that you might have, whether it be personnel or knowledge gaps, and just evaluate your readiness to migrate, to kind of get a feel for where you are. How close are you to actually being able to migrate? The next phase is migration readiness planning, referred to as MRP. This can be an 8 to 16 week engagement. So in this phase, we build a migration business case. We establish some cloud foundation through both in technology and in skills, people, and process. And so, we look at all those different areas and help companies improve with the people, process, and skills. We also put in place a landing zone, oftentimes in the form of AWS Control Tower. And then we oftentimes will look at performing a pilot migration of maybe one to two applications, or maybe do a POC if there is a need to prove out how something will run in the cloud. Again, that's usually an 8 to 16 week engagement. And then the final phase is the migration at scale. And so this typically, at least for larger companies, would be a 4-month or more engagement. And this is where we execute large-scale migrations and kind of take the migration factory approach to it, where you run through several iterations of moving applications in cycles to AWS. And we work on optimizing that process and optimizing the applications once they're in AWS. I should mention that depending on the size of company, you may not need to run through all of these phases. Oftentimes, for smaller companies, we may only do the MRA and MRP because maybe you only have 1 or 2 applications to move, and therefore we can fit that in that MRP phase. But if it's a larger, enterprise-sized company with many applications, then we would move on to that migration at scale phase. The last one listed here is a program by AWS called Database Freedom. It is a program that AWS provides some funding for, that allows you to migrate between or to a different database engine. And so maybe you are running Microsoft SQL Server on premise and you want to move to AWS, but at the same time, maybe you want to save money on those licensing costs and move to MySQL or Postgres. And so this particular program helps you make that move from one database engine to another. And so we help you with the schema conversion. There's some automated tools that can help with that. Whether or not those tools can do some of the work for us and make it more of a turnkey, or at the very least, oftentimes those tools may tell you here's how to convert the schema for the most part, and then these particular areas need additional attention by your development team to make some changes. And again, the goal of this is usually to eliminate licensing cost of databases and move to an engine that doesn't have those. And we'll also help you refactor any code that might need to be changed to match that new database engine. And so those are 4 offerings that we have, and those are kind of all dealing with migration in general. And in all of these, I should mention that MAP and the database freedom are all backed by AWS with usually some funding incentives. And so AWS will help pay for that cost of migrating to AWS. The next slide here is some application modernization offerings we have. And the first one listed here is a 6+ week engagement for a full-scale application modernization. So again, if you're maybe looking to go from a monolith to a microservice architecture, or just provide some other tech stack updates for your application, maybe move from one technology to another. This would be an area where we could help you with. So the first step would be to review your existing application, to become familiar with it, and then to create a roadmap for where you want to be. What is it that you're trying to do with the application? Are you trying to go to microservice? Are you trying to change technology? And then to execute that modernization, we have a very large development team in-house at ClearScale, and can help you perform that and work alongside your team, or it can be more of a turnkey type situation where you just want us to go perform that modernization and get you to the optimal state. And then we'll help you deploy that application in AWS. And again, 6+ weeks, meaning here that typically something like this can't be done in less than 6 weeks. I mean, by the time we learn the existing application and do the work and get it deployed, it's going to be at least 6 weeks to do something like that, oftentimes longer. The next offering is the data store modernization. And so here we're looking at your current data stores. Again, potentially could be changing technologies, or just moving or changing the data structure. Maybe you're all in on a relational database, but we could come in and take a look and say, you know what, for this data set here, or for this use case, maybe a relational database is not the best choice, and kind of look at on a case-by-case basis at what's the best fit for the different use cases in your solution. And so we could perform that audit to take a look at how, or what and how you're using data stores, map out what the future data stores would look like, and then execute those changes to update both the data stores themselves and the application logic behind it. Again, it's going to be a 6-week or more type engagement to do something like that. And then the last one here is an application enhancement. This would be, maybe adding AI or ML. Maybe you want to have an application that you want to add something like AWS personalized to make some suggestions to customers, or something along those lines. It doesn't have to be that, but so basically we can identify the app that you would like to investigate one of these enhancements, quantify that potential value, and so kind of building the business case for why you can do this, or what the outcome would be. Is it to save money? Is it to grow revenue, gain more business? And then we would help you execute that integration with whatever technology you were looking at. We have a vast team in ClearScale of developers, data engineers, machine learning. A team that has worked with lots of different technologies, lots of different companies, and we definitely have that expertise to help build in these enhancements. There are other offering details available in the handout section that you can take a look at. And now I think I'm done, Jay.
Excellent. Thank you, Robert. Appreciate that. And again, just to reiterate what Robert just said, you can find those handout details on the offers within the handouts tab. There's also the ability to book a meeting. So if you are interested in anything that you just saw, or just want to talk to somebody about your serverless and containers journey and determine where you want to be here in 6, 9, 12 months, we're happy to have that conversation with you as well. But now to the meat of our presentation. Let's get to these labs and dive into the world of unicorns. So I will pass it over for Alan to get us started and help us get us booted up.
Great, thanks, Jay. Welcome, everyone. So my name is Alan Litz. I'm a solutions architect at AWS, and I'm also very passionate about serverless and containers. And today I'm going to be taking us through the setup portion of this lab exercise. So we're going to be configuring a sandbox environment with a monolithic application, and then I'll pass over the reins to another colleague to then containerize that same application we've deployed. I do see we are a little bit ahead of time, so I was going to take maybe 3 minutes to give everyone a quick break, go top off some coffee, run to the restroom real quick, and maybe we'll get started in 3 minutes. So we'll get the links to the lab sent out on the chat as well, and then I'll take everyone through an exercise of getting everything set up. So we'll come back in 3 minutes to begin. Jay, if you're running the presentation, could you paste the link to the event engine, please?
I can.
Thanks. Okay, it is the top of the hour now. Welcome back. We're going to get started. So there are two links that are going to be critical to running this lab. And first, I'm going to talk about what we're going to do before we actually jump into our sandbox environment. The first link that we're looking at, which I've posted in the public chat, is a link to the instruction set for this lab. It's called the Iterative App Modernization Workshop. So you should be able to open that in the browser of choice. It is best to use Chrome if you can. It is also important when we go through this, if you do have a AWS account that you use regularly for your regular role function, you might need to use an incognito browser or clear the cache of your browser in order to access this sandbox environment. So if you want to go ahead and do that now, either open an incognito window or clear the cache of your current browser. And then click the link to the website instructions in the public chat. Additionally, it is really beneficial to use two screens if you do have the availability to use two monitors, to have the instructions open on one, and then we're going to be working in the AWS console on the second screen. Alternatively, you could do a side-by-side split with a single monitor or simply flip between the browser tabs. That's also perfectly fine. Just a lot more screen real estate would be beneficial if you do have it. So starting on this app modernization workshop slide or web page for the architecture section, what we're going to be doing is first deploying a Spring Boot Java application to an EC2 instance. So this will be our traditional monolith running on a very traditional server stack here with a regular EC2 instance, running our application with an RDS MySQL database as our backend database. And our intention today then is to take the functionality from the inventory of our e-commerce site, the users who log into our e-commerce site, and the basket of items that they add to their cart, to be able to break those functionalities out into different microservices and run them either in a serverless manner on Lambda functions or in a containerized environment using ECS. But first, we need to actually deploy this application before we can break it out into those different components. So after we go through these setup steps, our application will evolve to the next screenshot here, where we will add an API gateway to front end our application and provide that integration layer to our microservices. And then we're going to take that basket functionality and port it out into a Lambda function, take it out of our monolith and create a dedicated microservice with a DynamoDB database backend. The final evolution will then add an ECS component to replace our EC2 instance and provide additional containerized microservices using the same API gateway that we configured in the setup steps. So again, we're going to go through these steps here to configure the monolith, and then we'll work towards the microservices in the next modules. So in order to access the sandbox environment that we're going to use for the duration of the lab, there is a stickied link at the top of the chat. The link begins with dashboard.eventengine.run. If you could click that link for the dashboard, it will take you into the team dashboard and assign you a provisioned AWS account. And what this looks like is, if I were to open the team dashboard, you'll see this splash page with the terms and conditions, and a hash code has been entered for you. You'll want to accept the terms and conditions after clicking the link. And then you're going to sign in with an email one-time password. If you were an Amazon employee, you'd use the other links, but because you're doing this as an external, you'll use the email one-time password, and it will generate a password for you, and then you can be authenticated into the team dashboard. I'm going to, however, click the Amazon employee, and I need to authenticate. And you'll be taken to the team dashboard. So I'm going to give 1 minute for everyone to enable or ensure that you reach this step, because this is critical. Okay, so once you're on the team dashboard here, the first step we're going to do is set our team name. There should be a green box at the top control panel for setting the team name. you can just assign that to your own name, what this will allow us to do is if you experience any issues during this lab, we can take you into a private chat with a moderator, and they can help troubleshoot any issues you might have by actually accessing your console directly. And they'll be able to find your console in the list of all the participants based upon the name that you choose for your team. So if you just write your name and click Set Team Name, that will then put you into our list for troubleshooting if needed. That might take 30 seconds or so for the actual team name to be set, but then it will appear like it just did right there under the team name. Okay, next we're going to access the AWS console from our team dashboard. So there's an AWS console button. We're going to press that button. And then the login link is the first hyperlink, says open AWS console. There's also CLI access credentials here. We're not going to use those for this lab, but if you are comfortable with AWS CLI, you could use those credentials. So we're going to click the open AWS console link here. And it's going to take us directly into AWS. So we're going to follow along again with the workshop studio guide and complete the first module. So we're going to navigate in our studio guide to module 1, Monolith. So again, we're deploying a Spring Boot application connected to a MySQL database, and we're going to verify that the backend services are working properly and that our front-end website is also working, and then finally connect the two so that the front end talks to the back end. Because right now, all we have are just our raw infrastructure deployed in our environment. We want to make sure that it's all working.
Hey, Alan, if you don't mind, I'm going to spin up a quick poll just to make sure that people are all logged in and ready to go. So I'm firing up that poll now. If you can just let me know if you are ready for the lab or still working to log in. Again, if you are having problems logging in, use the chat. Let us know if there's an issue with the hash. If it says that there are no more seats available, we have backup hashes ready to launch as well. So please let us know kind of what you're seeing on your end, and we'll make sure that you get taken care of. But Alan, initial results that I'm seeing right now, it's about 90-10 or so are kind of ready to go. So again, the 9-10 people that are still having challenges logging in, use chat. Let's get you taken care of as soon as possible.
Great, thanks, Jay. Again, reminder, you might need to use an incognito browser or clear your browser cache before beginning this, especially if you use an AWS account for your regular work. Reminder, the studio guide is pasted in the public chat. I see Christian replied with the link again. It begins with catalog.us east 1.
Mm-hmm. And we can only have one sticky note at a time. So right now I still have the event hash at the top of the chat, which lets you get logged in. As soon as we are all kind of off and running, I'll make sure to update that so that we have that link as well for everybody. But it looks like Christian has replied a few times here with that link.
Great. Okay, I'm going to move on now to setting up our Cloud9 environment.
All right.
So the first section under Monolith is we're going to deploy an integrated development environment called Cloud9, which is going to allow us to run commands at the terminal to configure resources within AWS. Rather than having to provision a server, this is going to handle that entire authentication piece within AWS, and it's going to allow us to run commands directly within AWS. So Cloud9 is a separate service, and we're going to navigate in the console by using the search bar, typing in Cloud9, and just follow along. Click on Cloud9. On the splash page here, we're going to use the orange create environment, and we're going to assign it a name. So there is a name listed in the Studio Workshop Guide called environment name app modernization Cloud9 environment. So you can copy that name, paste it, and then click next step. We're going to leave everything default here. So it's going to create an EC2 instance for us, a T2 micro size, and deploy Amazon Linux 2, all pre-configured. So we don't need to change any settings. Scroll down to the bottom and click Next Step. And then finally create environment. We don't need to change anything else. So this will take a few minutes to launch that EC2 instance and bring us into our IDE. So in the meantime, we're going to go back to our studio workshop and we're going to talk about what we're going to do for the setup so we understand. So there are going to be a number of commands we're going to run at the command line terminal. It's not super important to understand what these specific commands are doing because they are simply configurations such as installing certain packages like Boto3 or updating Python, updating other aspects of the operating system. So I'm not going to go through every single command here, but we will see headers of the different sections such as increasing disk space or pulling down files and changing certain things in those files, which will be used for the configuration here. Later in the lab, we're going to use Cloud9 to configure our ECS and Fargate tasks. Those commands will be critical to understand how to create microservices and manage an application. So there we'll go into more depth on what those commands are actually performing when we execute them. Yeah, keep in mind, Cloud9 is not launched automatically within this environment. We do need to manually create that. So I see some in the chat about no Cloud9 available. You will need to create your own Cloud9 environment. Okay, so my Cloud9 is finished spinning up. We do have a splash page here. We can actually just close out of the splash page using the little X arrow. And I'm going to close out of the bottom window here. So I have just a blank gray screen. And I can close out of the AWS toolkit as well. We don't need that. And using the green plus arrow or plus mark, I'm going to open a brand new terminal. So if you just do the green and new terminal, this gives us command line access within AWS authenticated. Okay, so the next steps are we're going to be copying those commands from the studio guide and pasting them directly into our Cloud9 environment. So really it's going to be as simple as every section here, we're going to start with increasing the disk space. We're going to click this copy in the top right corner, and it's going to copy all of the code. We're going to move back over to our Cloud9 and simply do a Control V, and it will execute that command. So you just need to wait until the command fully completes and move on to the next one. The first command will reboot your Cloud9 environment. Because it's increasing the disk space, it does need to reboot. So once you run that command, you will need to wait another 2 minutes or so for the entire instance to come back up again, and then you'll get your command prompt back. Again, the commands are all in the Workshop Studio Guide. I'm on Module 1, Monolith, the first Cloud9 setup step. And so we've simply created a Cloud9 environment in our console, and now we're on the second step of increasing the disk space. Again, we're copying the command block using the copy button in the top right and pasting it into the Cloud9 environment. So while that's still rebooting, we're going to move down to setting up our environment variables. Next command will be making a directory and changing our directory. And go ahead and copy that command. Again, understanding what all these commands do is not super important at this point. It's just for setup purposes.
Hey, Alan, go
Yes.
ahead. Slow down just a touch. I think we're having a couple of folks that are falling behind on you a little bit. So just bring the pace down a little bit. Thank you,
No
sir.
problem. Yep, if you're having issues with Cloud9, you could just create another Cloud9 environment. That's perfectly okay to do. Okay, so we're moving on from increasing the disk space to now setting up the environment variables. Section number 3, So I've copied the command for making the directory. And my environment's back, so I'm going to paste that command. Yep, I'll pause again in case you need some more time for your EC2 instance, or your Cloud9 environment to reboot after the first command. I'll just take another second pause. Okay, moving on to the next command, 3.2. Here we're going to be writing the environment variables to this directory we just created. So we're going to copy this command. This is going to also upgrade our AWS command line interface, install JQ, and gather all the environment variables that our CloudFormation template created. So again, paste the command in the terminal and wait for it to complete. Okay, moving on to the next command, which is the stack name. We need to make sure that our stack name is set. At the end of the previous command, there should be an output that says stack name set to. And so if the value is not set to anything, if that is blank, then we'll need to set the stack name. If it does have a value, such as mine, where it says stack name set to mod dash and then a random string, then you're good. That is what we want. And we can move on. If you do not have a stack name set, no problem. There's another command to run to set the stack name. So only run this command if you don't have a stack name set. So the stack name set 3.3 is only run if you don't have a stack name. Okay, I see some comments in the chat that we need a little bit slower, taking some time to set up Cloud9 still. Again, we do have instructions here to follow. So if you miss my live showing of this, you can read through the guide here. It will take you through all the steps one by one. So as long as you follow in order from top to bottom, the Cloud9 setup, you should be able to be right in line with us. Yep, if you're getting an error unable to run AWS Toolkit, you can exit that error. It's not relevant at all. You don't need to click to refresh the IDE. Question on how to set the stack name. If it's not set in the previous command, then you would use 3.3 to set the stack name. It should be set in 3.2 command, but if not, then we use 3.3. Yep, I'm just going to go through this one last time for the chat. So we're on the Cloud9 Setup, section 3.2. We ran a command to set our environment variables. And at the end of that command should output a stack name. If the stack name is not set, though, then we need to run 3.3 to set the stack name.
Just to clarify for Nikita and others who are not seeing the stack name being set, open a new tab to CloudFormation in console, and you should see at least one stack. In the CloudFormation page, you would see at least one stack that starts with a mod hyphen something. So set that value as a stack name.
going to show what that looks like in case you need to see. So if we navigate to CloudFormation, we can see our stacks and grab the stack name there to set it. So we would copy the name of the stack here if the stack name is not set. And then we would run the stack name here and paste the value in the quotations that we copied. Again, if you're getting an output from the 3.2 command of the stack name mod dash random string, then we're good to go. You don't need to set it then in 3.3. Okay, moving on now to 3.4. So again, we're going to copy and run this command to create a map file of all of our environment variables that we're going to use throughout this lab. Again, simply just copy in the top right and paste into the terminal in Cloud9. And we can see the output of that command created a number of environment variables such as our stack name, our asset buckets, and most importantly, our public EC2 DNS endpoint. We're going to be using this value multiple times throughout this lab. So just take note of it at this time. You can copy it to a text editor if you wanted to keep it handy. Otherwise, we'll be referencing it by accessing this map file throughout the lab. But nothing to do at this point other than move on to the next command. So we've just run 3.4. Now let's move on to 3.5. Actually, the last command here is to actually just open the file again with a cat command, just to verify its contents. And that's just a cat the file to open it and to view and make sure that those values are set. Okay, moving on, I'm going to allow the chat, if you have questions or need help, for our moderators to take people into private chat to help troubleshoot if Cloud9 is still giving issues. Again, all of these instructions are in the Cloud9 setup here, so you don't necessarily have to follow live. You can just read through and copy them at your own pace. But I'm going to move on now to verifying our monolith deployment. Okay, so we're actually going to be skipping the next section called backend deployment. The reason why we're skipping this section is when we created these sandbox environments for you, we deployed a CloudFormation template in your consoles that created all of these resources for you. In this section, you could deploy this all manually, but we're going to skip that in the interest of time because we've already done it for you. If you navigate to CloudFormation in the console, if you were to search in the AWS console for CloudFormation and open up the stack that was created, you are able to see what was created in this CloudFormation template. Not necessary for this step, just wanted to make sure you're aware that the resources for this lab have been created via a CloudFormation template with infrastructure as code. So we're going to be skipping the backend deployment and going next to the verify backend section. So again, moving on to the verify backend section, we're going to navigate to CloudFormation. Again, accessing the mod dash stack name. And within CloudFormation, we're going to access the outputs tab. And the outputs tab is the same data that we just wrote to our master map text file. Same exact data. So we just want to verify that it's there as well. It is. And what we're going to do is we're going to access this public DNS endpoint to verify that our application is running. So this is our EC2 instance IP address. And we're going to verify that we're receiving data from that application. So we're going to copy that DNS name, open a new browser, paste that DNS name, and add after .com a /unicorns. So just the word unicorns. And paste the DNS name /unicorns. And we should be receiving back a JSON file with data from our application. So in browser, we don't need to read this data. We just want to make sure that we actually get data back when we navigate to that URL. So again, we're verifying that the backend application is serving us data. If you're having trouble getting to CloudFormation, remember in the console, you can go to the search bar and just search for the word CloudFormation and click on it under services. Then you access the public DNS under the Outputs tab on the stack name. Paste that into a separate browser tab with the /unicorns. Okay, so we're verified that that works, which is great. Now we're going to verify our front end, so the actual website. Our website is being hosted as a static website in S3. What this allows us to do is have a powerful hosting solution that auto scales to our needs and doesn't require a web server to be running full time to host this website. So what we're going to do is navigate to our S3 service in the console and click on the link within the bucket. Click on the public website link within the uni bucket. So we're going to go back to our console. Here I'm just going to navigate away from our CloudFormation page and search in the search bar for S3. So we're going to go to our S3 service. And here within S3, we should have 2 buckets listed. I'm going to make this a little larger so we can see. The first bucket should be our stack name dash asset bucket. The second bucket should be stack name dash uni bucket, or UI bucket, I'm sorry. We're going to be using the UI bucket for this portion. So the second bucket name, we can open that bucket by selecting it. And here we see a number of objects in the root of our bucket. What we're going to do is navigate on the Properties tab. So the second to the right of the Objects Properties tab, and scroll all the way to the bottom of our properties. And at the bottom of our properties, we have a static website hosting and a link to the endpoint of our static website. So we're going to click that link, and it's going to open in a new browser our unicorn shop. So this is the front end website of our e-commerce site selling unicorns. However, we see right now that we don't actually have any unicorns that we can add to a cart or buy. We just have a blank splash page, which means that our front end application, our front end website is not connected to our back end application. So the endpoint needs to be updated in the front end to allow us to query the data about these unicorns and then interact with them. So that's their next step. Yes, we skipped the backend deployment section. So we had a comment in the chat. Going back to our instruction set, we've skipped the section called backend deployment and did a verify next instead. I'm going to take a pause for a minute, make sure everyone needs to catch up. I am actually next on the verify front end section. So that's where we've moved to next, verify front end. Again, we opened up the website from S3 in the console under the static website hosting section, which is on the properties tab under our bucket. So if you open our bucket called UI bucket, we navigate to properties and then scroll all the way down to the bottom of our properties. We can access our static website hosting link. Okay, the next steps are to now connect the front end and the back end. So I'm going to scroll through our instruction set. This is the intended website we want to get to, where we have our splash page with the different tiles of different unicorns to purchase on our e-commerce website. This is what we will see once we actually complete this next step. So we're going to scroll down to 2.2. So using our Cloud9 environment, we're going to pull down and download a config.json file from the UI bucket. We're going to modify the endpoint in that file and re-upload it to S3. And that's going to connect our front end and back end. Again, the commands here aren't super important to understand. It's really just pulling down a file from S3, changing a value, and then re-uploading. So we're just simply going to copy and paste from 2.2 onwards into our Cloud9 environment. So starting with 2.2, under the verify front end section, we're going to copy that command and go back to our Cloud9 environment. You might need to reload if your session expired. You just click the login button again. And it's going to reconnect. Again, you might get this unable to run the AWS toolkit and Git panel red error message. You can totally ignore that and just X out of that at the top. It's not relevant here. I'm going to clear my terminal to make it fresh. And we're going to paste that first command to pull down our config.json file into our app modernization directory. So it'll say downloaded config.json from S3 bucket. And then moving on to 2.3, we're going to update it with the EC2 instance endpoint of our deployed EC2 instance. We're going to copy 2.3 command. And again, paste that into our Cloud9. And we can see that the output of this, when we cat the config.json file, it's now updated with the endpoint that we saw in the outputs tab of our CloudFormation template, that public DNS. So if we can verify that that matches, then we're good. We can also verify that by going to the Unicorn shop and verifying it from there as well. Sorry, I'm going to close out of this. And now we're going to push that file back to S3. So we're going to replace the host variable value and then push it back to S3 to connect to the front end and the back end. So 2.3, the second command here is copying this and then pushing it to S3. So actually, this next step is the one that is actually setting the value. So the original host name was a placeholder that we had when we created this lab, and the new value should match the one from the CloudFormation output. Okay, the next step is re-uploading to S3. So it's 2.4. We're going to push to S3 now. Copy that command. This is doing a AWS copy command to that bucket. I see a comment that the config.json does not exist, or no such file or directory. You might need to re-download it from S3. So you might need to run the first command 2.1, I believe, or 2.2 to pull down from S3. Okay, so we should be able to see an output from this command that says uploaded config.json file and marked it for public read. It's very important that it says marked for public read. That's because this file is going to allow public access to our website. And if it's not public, then we won't be able to have access. Okay, so we just ran command 2.4 to upload back to S3. We could also do it as a supplemental verification step. If you wanted to, you could navigate within the S3 console to the actual config.json object and verify under the access control list that this object is public for everyone. So again, this is a supplemental step if you want to try it out. Within the bucket here, if we go back to our bucket objects, we can see the config.json is listed here. And we could open this object by clicking on it and then seeing the permissions tab and verifying that this read is enabled. Okay, moving on to 2.5. So actually 2.5 and on, we're not going to do for this lab. I'm going to repeat, we're not going to do 2.5 or on. And that's because this would be a manual update to the file. We did a update through Cloud9. You could also download and edit this file locally on your own machine using a text editor and then re-upload to S3. We're not going to do those steps. We did it all in Cloud9. So you can skip steps 2.5 and on. And what we can do that now is reload the browser we had for our Unicorn shop to verify that the front end and back end are now connected. So if we just do a refresh of our browser here, sorry, just 1 second. There we go. So I had to open this up in an incognito window. We also might need to clear your cache in order to get the cards to load. So actually, that's a good step here. I was refreshing my browser on my original website here, and I was not getting the cards to load. So I opened up an incognito window, which would then allow me to see the cards that were populated. So the front end and back end are now connected. You could also do a Control F5 to reload as well, yes. Okay, so from this step here, let me just do a open this up in another incognito window again. We do want to create a login now for this application. So what we want to do is actually open up our control panel within the browser by doing function F12. Open up our console within the browser. So again, that's function F12, and watch the flow as we log into this application. We're going to be using this in other parts of this lab as well. So here we're going to do a sign up within our e-commerce website. So once you get to this step here, this is a critical step of making sure that the cards are available. We're going to, at the top of this web page, sign up for our e-commerce website with a new account. So in here, it's not super important which values you assign. These are all testing values. So I'm just putting my first name and then a mock email address. So I would just use something like a@amazon.com or any mock email address that you're going to remember and be able to use at a later time. This is not housed anywhere, long term, so it's just used for this testing. So it can be any mock email address used. But we're going to need to know that email address to test this application later. And then the passwords I'm going to set is just unicorns. So I'm going to type unicorns for my password and click sign up. And in my console, I can see a response that says the UID was set with an email and the user is now signed up. Again, if your cards are not loading, try and open an incognito window. You do obviously have to have the previous steps of uploading that config.json file back to S3 first. That's a critical step. And then open an incognito or clear your cache to see the cards appear. But once we've signed up for the service, now we can add unicorns to our cart by clicking on any of the cards and clicking the add to cart. And we can see a response that says got the cart. It'll have a UID and a reply with got the cart. We're going to now create, in the next steps, an API front end to this application where that post application or post method is going to be handled through API Gateway, rather than a direct call to our application. So right now we're seeing a direct call to our application for adding unicorns to the cart. We're going to now create functionality to allow us to split out that application functionality using a REST-based API. So we can just keep this browser open. And I'm going to switch back to the previous browser. So we're going to be coming back to this in a little bit. I'm going to take a quick pause just to make sure we've reviewed all this. And I'm going to scroll down to the bottom here to make sure that we've covered steps number 4. So step number 4 under the verify front end was the registering within the application. We did that by signing up for the service with a mock email address. And we got back responses in our browser console. The user was created, and we were able to add or remove unicorns from our shopping cart. So that at this point, we know that our monolithic Spring Boot application is working. Okay, so now at this point, we've completed module 1 for deploying our monolith. We used our Cloud9 IDE to execute some commands. We verified our backend, verified our front end, and then finally connect the two. So we're seeing a poll now of, have you completed module 1? Please answer that poll, and we'll see if we're ready to move on to module 2. Jay, do you have a response rate for that?
They are still pouring in. It looks like probably, again, just about 80-20 have completed module 1. So for the 10, 15 people that are still wrapping up, hopefully you are close. Certainly if you are having trouble, I'm assuming many of you are being helped in chat by the wonderful support team that we have, across the board. So right now I'm seeing about 75% is saying that they are completed, and continue to count there. So let's give it just another minute or two for people to kind of catch up, and we can provide a little bit of support in chat, and then let's move on to module 2.
Okay. Yep, I'll just reiterate again. I see some chatter here about having no cards created. What you can try again to possibly get that to work is redo the front-end deployment section where we pull down the config.json file and then change the, run these commands to update the endpoint and then re-upload the config.json file. Just do the entire section all over again for front-end deployment. Possibly the config.json was not set properly, or maybe you missed a step and it was not uploaded to S3. Any of those could be reasons why the cards are not appearing. So complete that section again, and then again, open up the public website in an incognito browser, or do a hard refresh in your browser to see the cards appear. Okay, so moving on now to, I'm just going to go back to our architecture diagram briefly. The next section here, we've deployed our monolith on an EC2 instance. Now we're going to be deploying an API gateway in front of our EC2 instance to, again, build a REST-based service to allow for interaction with different components of our application. So we're moving on now to module 2, the API gateway. Yeah, this is the architecture here. So we're actually going to be skipping the first step called create API gateway. The reason is, in interest of time, we've actually set up the API resources for you automatically in the CloudFormation template. Typically in this lab, you would go through the exercise of actually building resources one at a time within the API gateway console, but we're not going to be doing those steps. And the reason because it just takes too long, and there can be errors that can occur. We want to remove that because we really want to get to the microservices portion of this lab. This is all still just setup of our application. And then really the things we want to learn later are the microservices and containerization. So what we're going to do is navigate to the API gateway in the console. So I'm going to go back to my console. Here I'm just on the S3 service page, and I'm going to search for API Gateway in the search bar. So here I'm going to select API Gateway. And under the APIs, we should have one listed called unicorns. We're going to open up that API by selecting it. And here we can see the structure of our API that's been built for us. So here we have a number of resources under our root. The resources would be the / paths, so unicorns, baskets, UUIDs, and then a separate user and login stack tree as well. We also have a number of methods in our API. We have a get method for our unicorns. We have a post and delete for our baskets, a get for our UUID, and then a post for our users' logins. And those would be the different interactions with our applications that we did on our front-end application when we logged in and we clicked and added the different cards to our bucket. These are the different functionalities that were built now in API Gateway to do those same functionalities that we were doing directly on our application. We can actually select these different resources and see how they're configured. So we're going to have to do a little bit of configuration here to make sure that they're working properly. And so the configuration we're going to do is set the endpoint for each of the methods. So for each of the methods, which are the get, delete, and posts, we're going to select it within the tree. And then we're going to select the top right card here called integration request. And the integration request defines the integration type. So it should already be selected as HTTP. And then separately, about halfway down, the endpoint URL. This is what we're going to need to change for each of our methods to get our API connected to our backend. So right now, there's a placeholder URL that was designated when the CloudFormation template spun up. We're going to need to copy and paste the actual endpoint URL, the one that we configured in the config.json file. We're going to need to set that value for each of these endpoint URLs by editing it. So what we're going to do is go to our app modernization, our Cloud9 environment. I can clear the screen here. There's actually two ways to get the endpoint URL. Here we can either cat the file called master map text. Right, we created this file in the Cloud9 Setup section, and it lists the public EC2 DNS value here. We can copy it here. So again, the command that I just wrote is cat and then master _ map.txt, and that queries from our app modernization directory the file, or pulls the file with that value. Again, copy the DNS name here, DNS endpoint. The other method is we could go to the CloudFormation template, or sorry, the CloudFormation outputs in CloudFormation console and copy it from there as well. So if you want to do it that method, you could do it as well. So here I've copied this value, and I'm going to come back to my API gateway. So this is very important that we do this the same way for every single method. We're going to edit with the marker edit here next to the endpoint URL. And we're going to highlight the previous endpoint all the way to .com, keeping the slash. So that's the previous endpoint, and we're going to paste. I'm just going to do a Control V and paste in the new endpoint URL. And then there's a confirm checkbox or update box circle next to the endpoint URL, and we're going to select that to assign the new endpoint URL. So again, that was copying the endpoint URL from our file we created in Cloud9, and then selecting the get method under unicorns, the integration test or integration request, and then editing the URL. And we're going to do that same step for each method here. So I've just done the get unicorns, and now I'm going to move on to the basket delete. So here I can select basket delete. and then integration request card. So click the link at the top of integration request, and then edit the endpoint URL here. Again, only up until the .com. You're going to leave the /unicorn/basket alone. So I'm going to highlight the previous value, Control V, and then click the update circle. So now that URL has been updated. So it should be endpoint /unicorn/basket. Okay, moving on to the post. So same step here. Click on post basket, integration request, and edit the endpoint URL again. And update. Okay, next is the UUID get method. So again, click the method, click the integration request card, and edit that. Just the endpoint up to .com. Next, we're going to move on to the user post. So user post, open the integration request, edit the endpoint URL. And then the last one is our login post. So click on login post, integration request, and then change the endpoint. Okay, so we've now set the correct EC2 endpoint or backend endpoint in each of our methods of our API. There's one final step we need to complete to enable this API. So if I go back to our workshop studio, just want to make sure we're all on the same page on the steps here. So here we've done, we skipped the create API and the create resources methods because those have been built for us in our CloudFormation template. We did edit the endpoints, which is not a step listed in the instructions here. This is a step we're doing just for this lab. It's actually listed here in this blue box that says, if we're running a workshop via a managed event, which this is, then the resources have already been deployed, but we need to confirm our API resources have been deployed correctly, and that required our endpoint update. So the last step now, which is part of the create methods section, if we scrolled all the way down to the bottom, because again, we're not going to create these methods from scratch. They've already been created. We are going to test a couple of them and enable cross-origin resource sharing on each of these methods. So if we scroll down to, I'm just going to go fast to the bottom, 2.9. So again, I'm on section create methods under the API gateway, and I've scrolled down to section 2.9. Okay, so we're gonna leave this open and we're gonna go back to our API gateway. And first, what we're gonna do is enable cores in each of our method. Again, cross-origin resource sharing is gonna allow our browser to communicate to the backend through this API. So I have to select each of the resources, starting with the /unicorns, and under the actions dropdown. So select the resource actions. There's a third from the top is called enable cores. And I don't need to change any settings here. I just need to click the blue enable cores and then yes, replace existing values. And when I do that, I should get green check boxes or check marks for each of the cores updates. So this is a critical step. Once you've updated the endpoint for each method. Now we need to update the cores for each resource. So I've done the unicorns. Now I'm going to move on to basket. Again, actions, enable cores button, and then yes, replace existing values. Next is the UUID resource. Actions, enable cores, yes, replace existing values. So this is a manual step, but is required. The next one is /user. Actions, enable cores, yes, replace existing values. And then the last one is the login. Actions, enable cores, and yes, replace existing values. Again, CORS stands for cross-origin resource sharing. Allows our browser to request elements from cross-origin. Basically allows our browser to communicate to the backend or application. So once we've done the CORS setting for each of our resources, our API is now completely built and ready to be deployed. We do want to test to make sure that it is operating as intended. So after we've done the CORS update on each of our resources, we're now going to test our methods. So I'm going to go back up to the unicorns resource get method. I'm going to select get. And there's a vertical test bar here. So I'm going to click the test link. And here we can configure a query string or some headers to test with. We don't need to actually do any of that. We just need to scroll down to the blue test button at the bottom. And when we click test, we should receive a status code of 200 and a response body of the same JSON data we received in browser when we first did our backend verification. All the way back about an hour ago, we did the backend verification. This is the same JSON data of receiving back the unicorns from our application. So now that request is flowing through API gateway rather than a direct call to our application. So we can, as long as you get status code 200, then we know that our application, or sorry, our API gateway is configured properly. And then supplementary, we can also test that our basket is actually working as well through our API gateway. So adding and deleting unicorns from our basket, we tried that using the front-end application, and we saw in our browser console that working. But now we want to test through the API. What we can do is use the code in section 2.19, or sorry, not 19, 2.9, under the create method section. So if you scroll to 2.9 and copy this JSON, here we have some values we can assign, such as a test bucket UID and then a unicorn UID to test to see if the basket functionality is working through our API. So we're going to copy this JSON. We're going to navigate back to our API gateway, and under the basket resource to the post method. And under the post, we're going to do a test again. So the vertical test under the client here. And in this, we are going to configure a request body. So we're going to scroll down to request body and paste the JSON we just copied from the workshop instructions. And the green text we need to replace with actual values, actual UIDs, in order to test this if it's working. And where we're going to get those values is from our browser console that we tried earlier. So we actually need to switch back to the unicorn shop that I left open from previous. So you're going to make sure you have the unicorn shop open, in a different tab or in a different window. And anytime you add or delete a unicorn from the cart, a console reply will list the UID of that of that action. So here, if I add to cart this unicorn, so this post is actually, I'm sorry, we need to actually deploy first before we can test this. That's right. But that's okay. We did a got cart previously. If you were able to do a got cart, a get cart previously, then you'll have a UID of different unicorns already listed. So we can copy that value from the console here, and we can paste it into the API gateway. And replace the text here, the green text. Again, it needs to be in quotations. Actually, I'm going to come back here and just verify something. Just refresh. I think I needed to log back in. Just 1 second. So you do have to be logged into this web page for this to work. So I'm just going to log back into the e-commerce site using my credentials that I configured in the setup. There we go. So it actually logged me out of the application. That's why I was not seeing this. So there's actually 2 UIDs. Anytime you add a unicorn to the cart here, you click on a card and you click add to cart, you'll see a response in the console of 2 UIDs. The first is the basket UID, and the second one is the unicorn that's added to the basket. So we're going to copy the first UID, and it might be difficult to actually select that, but in the console, you want to highlight the first UID and paste that into the green text of your JSON here. And then the unicorn UID will be the second UID listed in the console. So we go back to the browser console, and I'm going to copy the second value here. And replace the green text. And these steps are just to verify that our API is working, because it's going to do the same functionality we just did in the front end by actually manually adding to the bucket. We're going to do, we're doing that, for forcing that using a test value in our API gateway. So I click test here, and I see a status code of 200, which is good. Response body will say no data, but that's okay. What that just means is that the data was added to the cart or to the basket, but nothing was returned. We do have some logs here, so we can see this method request authenticated properly and is working through our API gateway. So again, we're testing the basket post. So that was the basket resource post method, and we just provided it with some data from the front-end application that we tried. Grabbed some UIDs by adding a unicorn to a basket, and then copying the basket UID and then the unicorn ID separately. I know it is kind of hard to see in my console here, but in yours, let me see if I can actually make this larger. There we go. Like I increased the font of my console. You should have 2 UIDs listed in your console. The first one is the basket, the second is the unicorns. Paste those into the request body for the test and run the test. So at this point, we know that our API gateway is working. We just now need to deploy it and connect it to our application. So I think, is there one more poll, Jay, to make sure that this is a critical step?
So I have our next poll for when they've completed module 2.
Okay.
And then after we complete module 2, we'll go to a 10-minute break for everybody, and then we'll return for a short presentation and 2 more modules to wrap up.
Great. We're very nearly finished with module 2 then. So the way we deploy our API gateway is we're going to go back to the tree, and we're going to click the root of our API. So that's the / at the very top here. And we're going to do actions, deploy API. So it's under the API actions in the dropdown. Again, critical step was we needed to enable cores in each of those resources. So if you have not done that step yet, you don't need to do it again, but we need to make sure that cores is enabled. So every single resource you need to click on and do the actions, enable cores before we do this deployment. So that is a critical step if you have not done it yet. But to deploy now, we're going to do the root, actions, deploy API. Under deployment stage, we're going to select dev. There should be 2 different stages, but we're going to select dev as our stage. And the description here, we can just put development. And we're going to click deploy. So now we receive what's called an invoke URL. This is the new endpoint for our API gateway that's going to allow us to communicate to our application. And so now we can test to see if this API is connected to the backend by opening this in the browser and querying to see if we can get that same JSON data of the unicorns that we did when we verified the backend previously with the old endpoint. So again, we're testing a new API gateway endpoint versus the EC2 endpoint that we received previously. So we're going to copy that invoke URL. We're going to open a new browser tab. We're going to paste that URL. And I didn't copy it properly. Sorry. It ends with /dev, and we're going to add a /unicorns at the end, just like we did in the verify step previously. So if you're getting a missing authentication token message, it's because you didn't add /unicorns to the end of the invoke URL in browser. So if you have it as just /dev, you're going to get a missing authentication token. Just add /unicorns, and you'll receive back a JSON payload from our application. All that's doing is verifying that, yes, our API is working, it's connected to our application, and it's returning data. That's our verification step. Okay. At this point, we are complete with our API deployment. And now we just need to update our front-end config.json file with this invoke URL so that it now has a new endpoint to connect to the backend. So under the deploy API section, I've kind of moved ahead of the actual instructions here already, but if we go on to module 2 API gateway deploy API section, we've done step number 1 already, right? We've enabled cores on all resources. We then did the deploy API section 2 here, and we tested the URL, the invoke URL under section number 4. We copied that link into a browser, second browser tab, added the /unicorns, and we received back a JSON response. So we've done all these steps up to step 5. So now we're moving on to step 6, which is updating our config.json file with that invoke URL. Again, we're going to use our Cloud9 environment to pull down the config file, update it, and then push it back to S3. We're going to copy these commands here. So under step number 6, under deploy API, we're going to copy that command, and we're going to paste it into our Cloud9 environment. Again, you might need to log back in since it's been idle for a while to your Cloud9. But here I've downloaded the config file again to my Cloud9 environment. And then the next section is a little tricky here in the sense that we need to replace, under this export API entry point, we need to replace under the arrows here, the API gateway endpoint that we were just given in our invoke URL. So we need to copy this command. And it's actually not good to use the copy in the actual window here because it copies the comment as well. And we just want this export API gateway endpoint. So I would highlight just the command. So export API gateway endpoint, copy that. So Control C. And then in our Cloud9, we're going to paste that command, but we need to replace the API gateway endpoint value now with our invoke URL. So I'm going to now delete backspace that text. So just the equal sign. So now we have export API gateway equals. And now I need to copy the invoke URL and paste it in this command. So I'm going to go back to my API gateway console and again, copy the invoke URL under the stages. If you've navigated away from this, it's under stages, dev stage, and then it's this blue invoke URL. We're going to copy that value. We don't need to add a /unicorns or modify it in any way. We just now need to paste it into the command in our Cloud9 to replace that placeholder and click enter. So now it's assigned that new invoke URL to our gateway endpoint. I'm just going to take a pause to make sure everyone gets that step. I'm not seeing any chatter in the chat, which is good. It seems like people might be following along good. And then the final step is uploading this back into S3. So here we need to update the config file using the next command. So the current version of JSON is pointing to EC2 instance. We've now updated it with the API gateway endpoint. And now we're going to assign it in the config. So we're going to do a copy in the top right of this next one and run this next command in Cloud9. And now we can see the output in Cloud9. The host name is now that invoke URL with execute-API instead of our EC2 instance IP address. And then the last step is uploading back to S3. So we're going to copy this command for uploading to S3. So this is command number 7 or section 7 here. Paste into Cloud9. And that uploaded our file config.json to S3 with the updated URL. And we have now completed all those sections and deployed our API. The way we can verify that this is working is navigate back to our front-end application and just do a hard refresh on this. So I'm going to do a hard refresh. And I'm able to add things to the cart. You might get an error add to cart in the console here. You can ignore that for now. That's because our database is not yet set up. But the got cart reply in console will verify that our API is now serving these requests rather than directly from our application. So again, I did a hard refresh on our Unicorn shop once I uploaded the config.json file to S3. And now I can confirm that our API is now serving these requests. Okay, so just to recap what we've done so far, this is all the setup steps. We deployed our application as a monolith on an EC2 instance, and then we built an API gateway and configured it to front-end our application, and now user client requests are going through our API methods and requesting data from our application. The next sections, module 3 and 4, are going to be building the basket functionality with a Lambda function, so splitting that out of the monolith, and then finally containerizing additional functionality for inventory and users. So I think we're going to take our break at this point, and I'll turn it back over to Jay. Thank you.
Excellent. Thank you, Alan. All right. So before we head to break, I am going to fire up one quick poll. Have you completed Module 2? As Alan said, the chatter in the chat has certainly dropped off quite a bit, which hopefully is a great indication that you guys were all able to wrap up the lab and we're able to follow along successfully. So we'll give it just a second for those results to come in. Again, if you have questions or need support or you're running into challenges, please do use the chat function. We also appreciate any questions that you can provide on a larger scale for our team. We're going to have a Q&A portion of our event at the end of today's sessions. So any questions that you have from there would also be great to have. So, all right. As we look at the poll results, it looks like 85% or so have completed Module 2. Certainly, we're going to go ahead and take this 10-minute break, and that'll give everybody a few minutes for stretching their legs and getting up and moving around. We'll be back at just before the halfway point of the hour. So I'm located Central Time, so 1:25 my time, but certainly wherever you are, the 25 mark. So we will be back shortly for a quick presentation, and then we will dive back into the world of unicorns. Again, thank you everybody for participating today, and look forward to helping you through everything. Also, just so everybody knows, on the support side, I am seeing that Matt L is raising his hand for some support possibly. Matt, if you're not raising it for support and you accidentally clicked it, I'm sure a support team will reach out to you. So again, thank you everybody. Back in 10 minutes.
Hey, I just wanted to add a note, Jay. I see some people might be behind due to other issues or just other things going on. Because you have the access to the instruction set here, you can do this all on your own. All of the instructions here are available to you, so you can follow them in line. Feel free to do this at your own pace. Work through this break even and catch up.
All right, everybody, welcome back to the AWS Containers and Serverless Workshop. Before we jump back into, again, the world of unicorns for Module 3 and Module 4 with Sava, I'm going to pass it over to Todd Schaefer, who's going to give us a quick overview of adopting the startup mindset when it comes to utilizing serverless and containers. So, Todd, now that we're back, it is all yours.
Great. Hey everyone, Todd Schaefer. I head up serverless go-to-market here at Amazon for startups. I'm an advisor to our startup customers who would like to refactor or build new from the ground up with serverless. And I've been here at Amazon for about 2.5 years, but prior to that, I'd been involved with Amazon kind of since the very beginning, where I was building on Amazon way back when EC2 didn't even have the concept of ELB. So you'd actually have to save your configuration to your EC2 machine. Or if you were like me, kind of stare at the screen blankly after you forgot to do that, and then you'd have to start all over again. But it's a long time ago nowadays, and I'm kind of excited about how far we've come, and I'm excited to be here. So let's get into it. The past decade has seen the rise of developers as technology has become more pervasive. For those of you that have been around for a bit, I'll remind you that WhatsApp and Angry Birds were released in 2009. Instagram and Uber in 2010. Facebook launched their mobile app, and Snapchat debuted in 2011. And TikTok came out in 2017. And the crazy thing about them is that just since 2017, it's been downloaded 2.6 billion times. It's kind of staggering, like how aggressive the app marketplaces has become. And I don't know about you, but it seems every couple of weeks I'm installing a new app just to see how it works, or if they're one of my customers, I want to see the interface they built. And the most recent app that I've installed is called Doggo, since I'm 6 months into raising an American bulldog named Chunk, named after the character in the movie The Goonies. But I digress. According to App Annie, which is a company that collects and distributes an app usage report, there are a lot of me out there, as there have been 258 billion apps downloaded last year, and that's only going to increase. Fun side note, there are over 1 million apps available in the Apple App Store, 2.5 million in the Google Store, and this isn't like linear growth either. It's compounding. I remember in the college days when we'd play rock, paper, scissors for who had to call in the pizza order, and now there's dozens of apps to have food delivered. In short, more apps inspires more companies to deliver their service or their interaction via an app interface. So there's this huge upswing of digital experiences where developers are making more and more of the choices around the technology, and they're making their preferences known. Whereas 5 years ago, tech like I represent, serverless and GraphQL and things like that, were hardly mentioned. Today, they're leading the way as core technology chosen by developers to rapidly build, ship, and scale apps. And so, what does the development lifecycle look like for building these web and native experiences? First, it begins with the concept, the dream, the vision. Then the devs figure out the technical demands and make those dreams a reality. For a company that's more than just a couple people, the modern approach to build apps is done using cross-functional teams working backwards from that original vision. And there are some critical decisions to make that have some magnitude of market impact. If you're going purely web, you're kind of leaving, the entire mobile space out of it. Maybe you have plans for mobile in the future, or, you're going mobile first and you'll do, web later. Then you have trade-offs even within there. Like if you're going straight to Swift for iOS while you figure it out, you're leaving Android guys like me out in the cold. If you choose to go with a framework that deployed to both operating systems, this isn't as true now, but, just a couple of years ago, it might not have felt as snappy or native as we've come to enjoy. And we can really thank React, Flutter, and Xamarin for helping close the gap there pretty significantly. And then comes designing the customer experience, where you're mocking the app screens and interactions to kind of drive that UX. At this phase, you have to start thinking about the backend, local storage, how to persist app data. And with fingers crossed, you can scale out to many thousands or hopefully millions of users. For new apps from the ground up with no existing data, you can quickly provision the backend directly from the data model and evolve the model during development. For building on or kind of extending existing services with predefined data stores and APIs, you have to massage those existing databases and APIs that are managed by other parts of the organization. This is where core capabilities that are built into the app, such as authentication, authorization, analytics, instrumentation to understand user behavior and app availability. And then you got to think about input features like speech recognition or maybe AI conversational bots, or in the case of unicorns, monetization via payments or ad serving. Once development is underway, it's important to optimize development workflow and delivery. You got to be able to iterate quickly on tasks without impacting production or other team members. Nobody wants to be the one that broke the build, and teams of all sizes must be able to collaborate. As the app moves from development to prod, it's critical for that CI/CD process to support unit and integration tests, so that you can kind of track that progress as it makes its way through that pipeline. And then finally, the day comes where you hold your breath and you release all that sweet work into the wild. Once it's out, you iterate based on customer feedback. If it's really bad, maybe it's coming over Twitter, or maybe it's really good if it's coming over Twitter. And then, more discrete ways of checking app behavior, just keeping an eye on your analytic data, which helps you understand how people are using your app and whether or not they're successfully accomplishing the tasks that you were hoping they would accomplish. If you launch an e-com app selling unicorns, for example, and sales are great on the website, but really lackluster in the app experience, you don't need to be a genius to know that there's probably some improvements that need to be made on that app. And lastly, one of the things you can do is cross-reference some of the ops data, like crash analytics, that can help you understand if and why users are encountering problems. And this is really the process that helps startups deliver rapidly. By using a modern development flow, you can ensure that bug fixes and corrective actions are implemented quickly, maybe just via a new release through good DevOps automation practices, or if you're really savvy, without re-releasing at all, just by using something like feature flags or backend data settings. And there's three main requirements that our customers have when they're developing their app strategy and development process. It's innovation, speed, and performance. Building modern, mobile/web apps demand that you create highly performant applications that are innovative and different enough while making it to market quickly. You need to be agile in development, testing, iteration, and scaling. The features you build need to be performant, provide the best user experience, and you really hope that your features increase user engagement, not decrease user engagement. Or maybe in the case of an e-com app, the less steps that you have to take, the better towards the transaction. Your foundational features may include authentication or accessing data securely, while other features enable a better user experience, like real-time and online-offline sync, or features that increase user engagement, like targeted push notifications. All the time, Nike is pinging me because I left something in my cart. And all of these features are dependent on the cloud. Whether you work for startups or large enterprises, the need for agility so you can innovate and respond to market and customer feedback faster is the same. Your app needs to scale quickly to potentially millions of users, have global availability, manage gigs, if not petabytes of data, and respond in milliseconds. Mobile and front-end devs building net new applications today, luckily, don't need to think about the applications of years past that may have been built with monolithic approaches that lived on premises. And I think all of us wish we could develop greenfield apps, but it's not always the case. And so being on agility, being fast is one leg of agility. It means removing roadblocks and speed bumps along the way so the developers can focus on developing. You have to ensure the backend services work tightly and seamlessly with the front end, and the dev and test are integrated and automated into that pipeline. The other leg of agility is that services are fully managed. You as a developer should not have to be concerned with the detailed implementation or configuration of a service. You just call the service as it's needed. These decisions shouldn't have a cost, like whether you switch or don't use a service shouldn't negatively impact your app. Coming from my perspective and a lot of the app world out there, really, you should be looking at deploying as many backend services serverlessly if you can. And then, kind of getting to the back end of this, to recap, our customers are building modern apps by changing, not just code or a tool set, but really their entire people, process and technology paradigm so they can innovate faster and more frequently, all while reducing costs and building more reliable applications. And so we are truly witnessing just a major shift, and it's driven by our customers working backwards from what they need to do to win in the market. Businesses want to win customers. To win customers, they need to build better products, to release products and features a bit faster, which requires faster and more frequent experimentation and innovation. And they need the ability to focus on differentiated business logic and to decouple software for speed and safety. We no longer live in a world with a single database or architectural option. AWS is providing ways for customers to kind of shrink that scope, offload the undifferentiated pieces, and letting you choose the right tool for the right job and automate as much as humanly possible. And by doing so, you can build modern applications that allow you to go out there and win customers. With that, thanks so much for the time today. If you're running behind, I hope you kept your eyes on the lab during my presentation. I'm not insulted. If you're on time and ahead of schedule, I hope you tuned in and learned something about the trajectory of how apps are getting developed today. And I will leave you to the second half of the day. Good luck and Godspeed, everyone.
All right. Thank you so much. And now we will move on to Saba to take over for Module 3 and Module 4, the microservices and containerization portion of today's lab. Saba, if you would begin sharing your screen and we can get started.
Thank you, Jay. Can people hear me?
Yes.
And can people see my screen? Yep.
It is loading. And it should be popping up any second now for them. All right. You're all good.
Okay, awesome. So I'm hoping that every one of you were able to finish the API gateway, the module 2, API gateway integration. Can we do a quick poll?
We did right before we
awesome.
went to break.
Awesome.
And I believe we were at like 90% before we left.
Okay.
So I think we are all set for Module 3.
Okay. So just to discuss the current state, what we were able to achieve so far was we first had a Monolith running on EC2, accessing RDS, and this setup was completed for you using CloudFormation templates. And what we did, the next step through Alan's help, was we actually introduced an API gateway, so the front-end UI application is talking to the backend through API gateway. So the API gateway acts as an intermediary. It can allow you to throttle the APIs. You can put in API keys and things like those. So you can allow only specific users to access. You can put throttling, rate limits. You can have authorization, authentication, things like those. So that way only the valid users are allowed to access your backend. And what are the other benefits that brings it along with it? You can basically start changing the backends without the front-end user knowing where the backend is, without being tied point to point to the backend. So what we did was we started moving from direct EC2 connection to something through API gateway. And in the current lab, we are actually going to replace some functionality with a microservice running on Lambda. So Lambda is basically function as a service. So we will start with Lambda. And to get started, I request everyone to go access the S3 console. So in terms of the workshop studios, the lab portion, we have already set up the DynamoDB. So we are going to start with Lambda, the method setup. People are able to see my screen and read it? So we basically have two jar files saved in S3 bucket. The S3 bucket name is asset bucket. So you should be able to see asset bucket on S3, and there will be two jars. The smaller jar would be named mono to micro lambda.jar, which is of 13 MB. So everyone able to access the S3 page in the AWS console. Go into the asset bucket, and you should see a mono to microservice lambda. So once here in the mono to microservice lambda, there would be a S3 URI. Copy that URL link for now. Okay. So now we are here. Let's actually open a new tab. Go to the Lambda service. So I'm going to type Lambda. So with Lambda, what you are actually able to do is provide a function or a code and say that run it for me without worrying about the underlying infrastructure. So AWS Lambda takes care of the scaling, handling the requests and things like those, worrying about the underlying infrastructure and everything. So you don't have to focus on those parts of it. So it handles the scaling portion of it. You can actually set the limits to say, like, this is a maximum number of concurrency I'm allowed to use for this function. So you can actually have higher prioritization, lower prioritization for your functions without worrying about, okay, where is it going to run? How is it going to be exposed? How do I handle the scaling of the instance for the function? So we are going to click Lambda create functions. And we are going to go with author from scratch. So before, okay, let's go back to the workshop studio setup. We are going to go with create functions. In step 3, we are going to create a new function called add unicorn to basket. So going back to the Lambda function, I'm going to paste add unicorn to basket. And the function is of type Java 8 on Amazon Linux 2. So there will be multiple runtimes available. So we support Golang, C#, Ruby, Java, Python. So we are going to go with Java 8. Under the other supported, select Java 8 for Amazon Linux 2. Architecture is x86. Those are default. Change the default execution permission to use an existing role. We already created a role for you. This role specifically allows you to access DynamoDB. So if you are dropping down, you should see a service role, Lambda role. So make sure you are using an existing role. Select that. Click create function. So basically this tells Lambda to start creating the configurations required for running a Java-based runtime function. So we have done that, but we have not provided any code as such. So now go back to the S3 bucket, mono to micro Lambda, grab this S3 URI. We are going to tell Lambda, use this particular S3 code that is already there. And I'm going to select Amazon S3 location. Save. So this basically makes Lambda pull down the code from S3. So if people are with me, so because the jar file is big, it's not allowing us to do like a editing. Other times, if it's like a simple Python file, you might be able to do like an in-place edit. So we have got the code. We have uploaded it. It is 13 MB in size. And the next one would be to edit the runtime settings. So basically the runtime settings, there is something called the handler that basically tells Lambda which particular function acts as an entry point. There can be multiple functions in a jar file or a package. So we want to tell Lambda to invoke a specific function for us to invoke for this add unicorns to basket. So going back to Workshop Studio, we will be able to see which function to use. So I'm scrolling down, and this is a function name. So in step 6, copy com mono to micro lambda unicorn basket impulse. So that's the package and the class name. And add unicorn to basket is the actual method. It's a static method. So we are going to paste that here. So we are going to edit the runtime settings for the handler. And instead of the default, we are going to override that with add unicorn to basket. We are done saving it. So what we did was we imported the Lambda jar file from S3, specifying that it is going to be using Java 8. And then we edited the handler method to say this is a particular function entry point that Lambda should use to invoke add unicorns to basket. So this is a microservice that was built to replace the previous monolith. Monolith basically had everything all in one single jar file. So the original application was a monolith that implemented all the functions all together in one big jar file. So we are teasing apart some portion of the functions into Lambda as a microservice. So the basket functionality is going to be created as a separate microservice. Adding items into the basket is a new microservice we are building. So we created a new Lambda service. The method name is add unicorn to basket. It uses a jar file that is coming from S3, which is inside the asset bucket in S3. And the jar file name is mono to micro lambda. What we did was we created the Lambda function definition stating that the method name is add unicorn to basket. It is of Java 8 and it uses an existing policy that was pre-created for you. And then we did an upload from S3 location and pointed it to this mono to micro lambda jar file. And once that was done, we then went ahead and edited the handler method to point to add unicorn to basket function. Let's go back to the studio, to the workshop lab. And so we are done with uploading the jar file using Amazon S3. We edited the method to point to add unicorn to basket. So we are done with the save. Now we can do like a quick testing. So we plan to use a payload that is similar to when you did like dropping a unicorn into a basket. So let's copy the sample template, go back to add unicorn to basket, and at the top there is a test option. So let's override that. And for the unicorn UID, I'm planning to grab one of the unicorn UIDs from the public DNS host name /unicorns. So I'm going to test this now. The very first time it runs, it kind of builds a runtime environment for you. So it is still executing. So it was successful and it reports added unicorn to basket. So this is a little different functionality where the microservice is accepting your basket and unicorn and reporting back that yes, it added the unicorn to the basket. So what is happening under the covers is Lambda is running a microservice, which in turn talks to DynamoDB. So we had also created a DynamoDB table. And if you're ready to go into DynamoDB, we should see a table, Unishop, and let's look at the items. So you can see there is like a UID of my test basket, and there are unicorns within it. There's a map. And this was a UID we attempted to add. So this is good. So the microservice is functioning. Similarly, we are going to add other microservices to delete things as well as to get things from the basket. So going back to the lab instructions, we were able to successfully test add unicorns to the basket. We were able to check in the DynamoDB service that the unicorn got added and it is being saved on the DynamoDB as a persistent store. We are going to add additional functions. So get unicorns basket. So go back to Lambda functions at the top. In functions, create a new function. Again, author from scratch. The function name is get unicorns basket. It's going to be Java 8. And in terms of the execution role, we are going to use an existing role Lambda role. Click create function. And we are going to upload the code from Amazon S3. So go back to S3 bucket, copy the S3 URI. All these functions are using the same set of jar file, but the entry points are different for each one of them. So now we added that. We need to edit the method, the entry point, the handler method. So for get, it's get unicorns basket. So let's edit the handler method. So now it is again unicorns basket impl, but the function entry point is get unicorns basket. So click save. So we are good on this side, and now let's do a test. For the test, it will be a simple provide the basket UID and see whether it can get those basket, the unicorns within it. So click test. Okay. Let's see whether it can retrieve the unicorn we added previously using add unicorn to basket. So the execution was successful. It was able to get the UID of the unicorn we added in the previous step. So what we did, we basically created the Lambda function as prescribed in the lab instructions. We said get unicorns basket. We chose the runtime as Java 8. We went with the existing role. And for the handler method, we went in and edited in the runtime settings, clicked the edit button, and we basically pasted this method from the Workshop Studio instructions. So we took care of the get unicorns basket. Now that we are done with the get and the post, we want to do the removal of a unicorn from a basket. A particular unicorn needs to be removed from a given basket. So we are going to create yet another Lambda function. So go back to Lambda functions. We want to create a function from scratch, remove unicorns from basket. I'm going to again select Java 8. x86 is default. For the change the default execution role, I'm going to go again with the existing role. I'm going to go with the service role that was already created for us that allows the Lambda function to invoke DynamoDB and access the data. So I'm going to click create function. So the function has been created. Now I need to upload from S3. I go back to S3, grab this S3 URI for the mono to micro Lambda function. So select again Amazon S3. Basically, we are repeating the same steps, except that for each one of these functions, the handler methods are a little different.
So if you could go ahead and take a moment. I think folks are catching up with you.
Okay.
I think it's they're falling a little behind on what you're doing.
Sure. So let's repeat this. So let me go back for the purpose of testing. I'm going to delete this. Yeah.
Sorry about that. Just trying to get my dog to stop. Yeah, I think just pause for just a moment. We'll give folks just a minute to catch up on it. I think they're just they're
okay.
Multi-screening it. I'll wave you when we get more.
Okay. So for folks going through this, let me just do for remove unicorn, and you can follow the same exact instructions in the lab. So I'm going to create a new Lambda function. Select create function, author from scratch, and provide the function name. In this case, it's remove unicorns from basket. We are going to do this in the Lambda console page. Select Java 8 on Amazon Linux 2. And in terms of permissions, we are going to use existing role. From the drop-down, select Lambda role and click create function. So we just created a brand new function, but it does not actually have any implementation or any of the runtime settings configured correctly. It is just bare bones that says it's named remove unicorn from basket. It is of type Java, and it uses an existing permission execution role. Now, in terms of the code, I'm going to upload it from S3. So I'm going to select Amazon S3. So go back to S3 bucket, grab the mono to micro lambda jar files S3 URI from the asset bucket and paste that here. So now we have provided the code for the Lambda function. We need to edit the handler information here. Basically, this was pre-filled with a sample template. So we need to edit it to match the specific microservice implementation we are using. So go back. For the remove unicorns, the function name is here. The class is unicorn basket impl, and the method is remove unicorn from basket. So I'm going to replace this handler method entry point with remove unicorn from basket, and I'm going to hit save. Was that okay?
Yes, so I think this pace is helping folks. Thank you, sir.
Thank you. So if we want to, we can actually go and test again how it looks. So we can try to delete. So let me go back to the workshop lab. For the delete function, I'm planning to test it. So there is a test tab right next to code, and paste the sample template you get from the studio or from the workshop lab notes. And in terms of edit unicorn, you can grab that either from DynamoDB or the previous one we grabbed from. So for the DynamoDB, go to AWS console, type DynamoDB as a service name at the top, and you should be able to see items on the left hand side, and you should be able to see a Unishop table with the items. So I'm going to delete this particular unicorn from the basket, which is named my test basket UID. So let's test this, see whether it deletes it. If this is not a valid UID that we added previously, then it would report an error. So it is deleting, attempting to delete. The spinning wheel shows. Okay. So what is the result I got? So unicorn was removed and the basket was deleted. So what did we do? We basically created 3 functions. All 3 of them follow the same step, where we create the function name, we following the workshop manual, one for add unicorns to basket, one to get unicorn from basket, one to delete unicorn from basket. All 3 of them would be using Java 8 as a runtime. They would use an existing role which was already pre-created for you that allows you to access DynamoDB. It would be named as service policy, service role, something Lambda role. And once that is done, we go in and upload the code from S3. The S3 bucket for asset bucket already has the jar file named mono to micro lambda jar file. Grab that S3 URI and use the upload from S3 location to paste the URI. for the jar file. So this way you are not manually downloading locally and then re-uploading. This is much faster. So once the code has been uploaded from S3, go ahead and edit the runtime settings where the handler information is expected. So it would be pre-filled with some example handler method. Edit that to replace with the right method name. And once that is done, save it, and then you would be able to test it for each one of them. Sounds good? Anyone having issues?
It appears we're in a good spot, Sava. I think we can keep moving forward.
Yep, keep the pace. It's good.
So we at this point, all of us should actually have 3 Lambda functions, and you should have been able to test it. It's okay still, like the function should work normally. Now that we have built the Lambda functions, we are going to let API Gateway call these new microservices rather than relying on the old monolith running on EC2. So that is the beauty of API Gateway. API Gateway hides the backend from the front-end people. So that way you can actually go in and say, okay, the Java makes sense for this particular microservice, or let me go implement with Node.js. So each function, each microservice can be running separately, independently, can be scaled up on its own accord, have its own dev release cycles, instead of everyone having to catch the train as part of a monolith. So people would be able to develop faster, test faster, have more agile development. So let's go back to API Gateway. So go back to resources. So what we added a set of microservices were dealing with the basket. So go back to basket. We are going to do a update for the post, the delete, as well as the get UID. So let's start with basket. So go back to API Gateway, go with the Unicorn's REST API and go to basket. And then let's go into post. So let me first change the workshop instructions. So we are going to be focused on integrate Lambda with API Gateway. So we are basically now going to call the basket, that is a set of microservices. So let's go with the post, and we will be editing the endpoint for the integration request. So going back to API Gateway, we are on the basket post method. Click on integration request. So right now it is pointing to a HTTP endpoint, which was your EC2 instance. We are going to change that to a Lambda function. So API Gateway allows you to replace the backend endpoints to be a HTTP or a Lambda function or a mock service or yet another AWS service. So we are going to rely on Lambda function. And for this one, add unicorn to basket. Once I type a, it starts showing me the set of Lambda functions. Add unicorn to basket, it starts automatically populating the region and other things. So let's hit save. So everyone should be able to see, once you select Lambda function and start typing a or add into the Lambda function text field, you should be able to see the full Lambda function start filling up. So change from HTTP to a Lambda function for the integration request and click save. So yes, I want to switch to Lambda integration, and it will say, are you going to allow API Gateway to invoke Lambda? Click OK. So it's going through the save. Let's go back to method execution. Let's do a test. So let's go back and test again with a sample payload. So for edit, for the unicorn, I'm going to reuse one of the unicorn's UIDs. I'm going to leave the basket UID the same, like some sample dummy UID. So I hit test and it's invoking it. Let's see whether it comes back with a response. It's still spinning. Okay, so it tried to invoke it and it reported added unicorn to basket. So this was a test of the post method under unicorn's basket, where we are trying to add a unicorn into a specific basket. So the basket UID can be anything, the outer UID. The internal UID needs to be a valid one, so grab it from the /unicorns method from the old EC2. So once that integration with the Lambda is complete, you should be able to test it and you should see a result. Earlier, the post method on the EC2 used to be a blank thing. Now we are actually getting a little more meaningful message back from the Lambda microservice that says, yes, I added your unicorn to the basket. So this is good. Let's actually save it for future reference. I actually have like a text pad, so I'm going to use this going forward. So let's next do a delete. So the delete again is going to a HTTP function. So go to the integration request. And right now it is a HTTP function going to the EC2 instance, Monolith. We want to change it to Lambda function. And this would be a remove unicorn from basket. So I'm changing the function integration type to be a Lambda function for the delete operation under unicorn's basket. And the Lambda function is remove unicorn from basket. Remaining things can be the defaults. I'm hitting save. It would ask me for permissions to invoke it. Yes. Okay, so let's try to test it. So we are going to reuse the payload we used to post something into the basket. We are going to reuse it to do the deletion. So we got the successful message that yes, unicorn was removed and the basket was deleted. Are we good so far?
So far, seems good.
Good. Yeah, the get method requires a little more complex steps. So I will wait for everyone to feel free before I dive into the get. So far what we did on the API gateway was change the HTTP method to be a Lambda function that we are calling for each one of them, whether it's a post. If it's a post, we are doing a add unicorn to basket Lambda function invocation. For the deletion, we are calling remove unicorn from basket. So we basically change the integration from HTTP to a Lambda function, and based on that particular calling method type, we go with a specific Lambda function. Okay, now let's go back to the lab nodes. For the get, we need to do a little more additional work. So we need to create a model because the Lambda function as a microservice is expecting a JSON payload, but we want to continue to rely on a get method for the front end to invoke a get unicorn from the basket. So we will use a model that would actually map the incoming get request into a little more of a meaningful JSON payload for the operation to continue onto Lambda. So we are going to the API gateway. We will click on models and click create. So navigate to the models on the left-hand tab, click create, and let's copy the instructions from. We are going to create a new model called unicorn basket, and we'll copy a set of JSON payload. So going back to the new model in the API gateway, we are going to call it unicorn basket. And for model schema, we are going to grab this. Basically, let's take a look here. So basically it says it is going to be of application/JSON type. So the model name is unicorn basket. The content type is application/JSON, and the schema is basically saying the title is unicorn basket, the type is object, and it actually has a nested property called UID, which is of type string. So this basically creates a JSON payload that can be handled as a model for API gateway. So click create. So we have created a brand new model called unicorn basket of type application JSON, and which actually has this particular schema. So now we are done with it. We are ready to go and start editing the get method. So go back to API gateway, into the get method. In the integration request, we are going to call a Lambda function. Rather than going with the HTTP method, we are going to call Lambda function. And this will be a get unicorns basket. So far, so good, right? We are going to accept the permissions for API gateway to invoke Lambda. So this was a straightforward one so far. But now we need to actually go and use a mapping template. So click on mapping templates at the bottom. Select the middle button, request body pass-through when there are no templates defined. So click on the middle option where it says recommended, and click on add mapping template. So type it as application/JSON. Select the tick. So now we are done with that. We are so far with me. So originally we kind of changed the type to be a Lambda function for integration, and we selected get unicorns basket. So far so good. Then we need to scroll down, select the mapping templates, select request body pass through to be the second option where there are no templates defined. Select that and type a content type as application JSON. So this mapping template allows API gateway to massage and recreate a different set of payload for the backend to accept. So we are going to create for unicorn basket. So it kind of comes up with some generated thing like UID is foo. What we want is the UID to match what the user specifies. So go back to the instructions in the lab, and we would basically copy this particular one, where it says pull the UID from the input params that the user is providing as part of the get URL path. So copy that, go back to API gateway, replace this. We are saying input root is the input given the payload, the input request, and from the input params get this UID and fill that as a JSON payload. So click save. We are done with that. Go back to the method execution. We are ready for the test. And in terms of the UID, it would be the my basket UID. I don't know if the basket is still there. I think it is gone because we deleted the basket. So let's see whether it can work or not. Spinning. So null response. So let's try a little differently. Let's first add something into the basket, and then we can actually do like a get. So I'm going to add something back into a basket with this particular UID and basket UID. So we now have an existing basket. Right. So yes, now we should be able to see like, are there any items in the basket? Yes, there is item in the basket. And let's go back to the get function and let's test the UID get test. So I'm going to, for now, let's use this basket UID, and that is in the path. So we are now ready to test, see whether it can really pull back. Yes, it is able to pull back the basket with the given UID of the unicorn. So it is able to go back to DynamoDB and pull the particular given basket that has UID within it. So the previous step failed earlier because we had deleted the basket. So now we have basically completed the integration of the basket related functionalities, adding an item into a basket, deleting an item from the basket, or getting items from the basket. We were able to replace the functionality that was handled earlier by the monolith with a set of microservices running on Lambda, and API Gateway handled everything for us now. So if you go back to the Unishop or the Unicorn shop, we should still be able to continue from here. So the cart is empty, so let's add that into the cart. So the cart, like I think it started logging in, and according to the UI, it is talking to API Gateway, everything is good. So it continues to work fine with the API Gateway acting as the intermediary between the front end and the actual backend, where in this case, the backend is coming from Lambda-based microservices rather than the previous monolith. So now what we have achieved is this particular architecture state. From this portion, we went into API Gateway, acting as an intermediary and calling the set of Lambda-based microservices to handle the basket functionality, adding an item into a basket, removing item, or getting an item. So far, so good. So we are done with module 3. People okay?
Yeah.
Are able to?
I think we're going to do a poll here. Yep, Jay just sent out a poll. But not a lot of chatter to suggest otherwise. So let's see what the poll says.
So how many of you are more interested in serverless or containers? The beauty of serverless is basically saying like, okay, I have the application developed, now get it up and running. I don't want to wait for someone to provision the infrastructure for me or to handle the scaling or handle like what is going on here. We basically support multiple runtimes, and sometimes you can also bring in your own runtime. And we also now support containers. So you can actually develop something in R, and earlier Lambda could not support R. Now you can actually bring in a container image and start running it. And it is basically like, okay, start spinning it up, start serving the request. So that's the beauty of Lambda, where you're, I think the integrations are failing. So probably the basket was, there is a double unicorns. So your endpoint is really bad. Double unicorns, that itself is bad. Okay, probably Stephen, one of you can help. Okay.
The initial responses are about 75, 80% saying that they've completed module 3. So I think for the most part, we can go ahead and continue on to module 4, and support will help certainly anybody and everybody that needs help as they finish up module 3.
Awesome. So let's step on it. Let's get into containers. So how many of you are looking forward to containers? Hopefully a lot. Okay, we are going to use extensively Cloud9 for a lot of the templatization. So we already have the Cloud9 environment set up. So let's start with the Docker image. So going back to S3, I hope you recall there is an asset bucket that actually has 2 jar files. One was the Lambda jar file that implemented the microservice functionality. There was also the micro legacy jar file, which is like almost 200 MB. So that is basically the legacy jar file, the legacy monolith application built using Java Spring Boot. So what we are planning to do is just create a container image out of it and start deploying it to run as a container on ECS. So we are going to create a Docker image from this particular jar file, create a task definition that references this and tells ECS, can you run this on these ports with these CPU and memory and configurations, and get it up and running and exposed to the public. So that way I can start scaling things up as I need to. Instead of running on one big EC2 instance, I can deploy it as containers. I can pack it faster. I can scale it up as needed without consuming too many resources. So we basically have this mono to micro legacy snapshot.jar on the S3 asset bucket. So let's go back to the workshop studio. We are going to check the Cloud9 environment still has all the things that we were expecting. So yes, there is a master.map text. I'm also opening it up here. People can see the font, can read the font clearly. So there is a stack name. That was a CloudFormation stack. There is a region value, which is US East 1. Each one of you have your own AWS account IDs. And it also has different endpoints. So one would be like a RDS, the database that we are using to manage the unicorns. There is the UI bucket, which is S3, and there is an asset bucket, and there is a VPC ID. We created a VPC for you. So this workshop material would be available publicly. It will be there forever. The test environment would be available for next 18 hours. So we already have this master map.txt file. So this already has the variables that we would rely on to build the next set of actions. So now we are good on the master map. Now we are going to copy over the jar file for the Monolith legacy application from S3 to the local Cloud9. So I'm going to copy and paste the command that basically says, given this asset bucket, I'm going to pull down this mono to micro legacy snapshot jar file. So we got that. So we got that file now on Cloud9. We are going to use that to create a Docker image next. So we are done with 1.2. Now we are going to create a Docker file that basically says, I'm going to use a Docker image based on OpenJDK 8, and I'm going to use this jar file and run it using Java. Okay, so there is a Docker file definition going to be created here using Cloud9. So let me clear the screen. So I'm going to paste it. So I created it, and you can see there is a Docker file. That basically, it's a simple one that says, I want a Docker container based on OpenJDK 8 image that would host a jar file inside and run Java on this application jar file. It's a Spring Boot jar file, so it is a simple set of commands to run the jar file. So far, so good. It would be requiring certain environment variables like the database. We will configure that later. So we are done with step 1.3. Now let's actually build the Docker image from this jar file using the Docker file. So it checks for the Docker file, it checks for the jar file, then it's doing a Docker build. So it's actually starting to build and start pulling down the requirements for OpenJDK Docker image and starts adding the jar file within the Docker image, and then finally it will tag it. So it successfully tagged it as AWS samples mono to micro legacy 0.1 version. Any questions so far with step 1.5? I'm going to run 1. Sorry, we are done with 1.4. We are going to run 1.5. So this is basically to make sure the Docker image is valid and it can run successfully. So I'm going to run it, telling the container to expose the port 8080 on the local host as port 80. So it's starting up. Okay. So you should start seeing the Spring initialization image, and it's kind of going through the bootstrap. So it started running. It is up and running in 18 seconds. This is like a simple Spring Boot Java application, nothing fancy. So you can get access to the code also if you want to build your own thing. So it is running on Tomcat. And it is up and running. So this is good. So the Docker image is able to actually run successfully the Spring Boot application using OpenJDK 8. So we are done with step 1.5. So we saw it get started. So we are ready for the next step, which is we are going to register this Docker image with a Elastic Container Registry. It's like a Docker Hub equivalent running within the AWS network. So we are going to create a repository called AWS Samples Mono to Micro Legacy and then push this Docker image. So I'm going to run step 2.1. So it started creating. So it ran it and it actually created a repository for me. So let's actually try to access the services. We quickly check whether the container registry got created. Yes. So there is a container registry created here. So for the time being, let me close off the Lambda, the DynamoDB portions of it, and even the S3, because we are done with the S3 portion of it. So we are done with the ECR creation, but it still does not actually have the Docker image. We are now going to tag it, and following that, we will push it to the ECR. So we are done with that. Now we are tagging it to be associated with the ECR registry. And the next step is to push it to the ECR. So what I did was I created a Docker image. Following that, we created the ECR registry. We then tagged the Docker image with this ECR registry, and now I'm pushing it to the ECR registry, the Docker image completely. So this is basically similar to like pushing it to Docker Hub. So each one of you would have your own account ID and the region and things for the ECR registry endpoint. Okay, so let's check on the ECR. Okay, yeah, there is a .1 version of the Docker image already uploaded, and it says the total Docker image is like 569 MB. So we are done with that step. So we are ready to move on to the next chapter, creating the easiest task definition. People able to follow this? What we did was we took the pre-existing jar file that belonged to the legacy Monolith application, created a Docker image out of it, and then tagged it, pushed it to ECR to be available for usage for future reference. Okay. Any questions? Okay, I will move on to the next chapter, creation of the easiest task definition. So if you go back to Cloud9, we already saw the create the master map.txt already has the different values we would be requiring, like the S3 buckets, the RDS endpoints, the VPC ID, the stack name, and things like those. So we will be relying on those to create the task definition. So going back to the workshop lab materials. So we already saw this. This would also be available in the CloudFormation stack outputs. So people can see it exactly matches what we saw in the master map. So now let's create the easiest task definition. So this is kind of like a templated one where it says region value, the account ID value, things like those. So these are pre-templated for you. We would replace that with the actual dynamic values. Like you might be running in US East 1 today, you might be running it on US West 2 tomorrow. So it can be different. And the IDs, account IDs, things though like those would be different. And for the Docker image to actually run successfully, handling the functionality, it needs to talk to the database. So we would be providing values for the database and other things like the S3 buckets and things like that. So let's copy the code here. Let's run this on the Cloud9. Sorry. So actually typed it into that one. Okay, so let's see what it created. It created something called the Backend Legacy App Template. So this is basically whatever we saw on the page with these templates, pre-filled templates. So now we want to replace these values. So let's follow the next step to replace them. So if you can actually take a look here, it also says what needs to be the port for the container to be exposed. If we want to run the container on 80, expose it on port 80 for the outside, and we want it to run with Fargate. Fargate is basically the serverless option for running containers, where you don't provision the infrastructure, we handle it for you. And we would be running operating system of Linux, and we would be using different modes like the CPU, the memory, the VPC, and things like those, and what kind of roles and policies, permissions it should require for it to run. So we basically have this template already saved now in the Cloud9. We are now ready for the next step, where we want to replace the account ID, the region, the RDS endpoint, and things like those with the actual values. So copy this code and let's run it now. So let me clear the screen and I'm going to run it. So what did it create? It created yet another file for me, which is the backend legacy app. So if you take a look, it basically has a container image pointing to the ECR registry. It has the region filled in. It has a database endpoint. It basically has the region, the UI bucket, and the asset bucket. It has other details already filled in. So we are good in terms of creating something called the task definition for ECS to know how to deploy your container, what characteristics, attributes it needs, like a CPU or memory or port or permissions, or what operating system it should use, things like those. So this definition, the task definition, tells ECS how to deploy it, how to run it. So we are done with this step. We wired all the parts together in this task definition file. Now we are ready to move on to the ECS console link. So let's go into ECS console. That is step 2.3. So ECS console comes up and I want to actually go into the task definitions on the left. So let's follow the lab instructions. Says create a new task definition on the left hand panel and create a Fargate launch compatible type. So go to the ECS task definitions, create a new task definition. Fargate is a very first option. As I mentioned, Fargate is the serverless option for you to run containers. You do have the option of running on your own self-managed EC2 instances. So Fargate is the one we will choose because we don't want to be managing the underlying infrastructure. And now, when I hit next, it is asking me to configure the task and container definitions. Instead of filling in these, what we will do is scroll down all the way to the bottom, and there is something called configure via JSON. So click that. It would come up with some default placeholders that says it is going to be Fargate, it uses network mode. So delete that option, go to Cloud9 and open up the backend legacy app JSON file, copy the whole thing, and go back to ECS, and for the JSON content, paste that and click save. So now when you go back, you should be able to see all the details filled in. So the task definition name would have been automatically filled as backend legacy app task definition. It is of type Fargate. It uses a task role, ECS task execution role. It uses VPC. It uses VPC as a network mode. Operating system is Linux, task execution role, memory, CPU, things like those. So everything is done for you once you actually have that pre-filled template created in Cloud9. So click create. It should go through and it is successful. I'll wait here. Anyone run into issues? Any raised hands? Everything good? Sure.
Yeah, I think other than the request to pause, I think we have most everything being addressed directly. I think otherwise you're good.
Okay. So what we did in this chapter was we used a pre-built template and refilled that with the actual values like your account or your region or your ECR registry endpoint or your database or your S3 buckets, and use that new task definition that was pre-filled with the other values like CPUs, memory, operating system, ports, things like those, and created a new ECS task definition that would use Fargate as a launch type. People okay so far? Are we good to proceed next to the next chapter?
Yes, I think we have about 15 more minutes before we'll start moving towards our final survey and the Q&A portion of today's event.
Okay. So that essentially completes the chapter 2. So we are done with the task submission. Now we are ready to go into the ECS Fargate task. So we are going to create a new ECS cluster where your Fargate would be running. The container would be running essentially. So the Elastic Container Service is like an easy on-ramp for you to start running containers. For those who are very much into containers and like the Kubernetes, you have the EKS ramp. So ECS is more of like the very soft, very smoother guided path. For those with a lot more power, they can go with the EKS route. So we are going to create a ECS cluster, name it Backend Legacy Cluster of type Fargate service. So going back to the ECS console, click on clusters on the top left, click create cluster, and we are going to go with networking only for Fargate. Next step. The cluster name is this, Backend Legacy Cluster. Make sure you are not clicking create VPC. Don't click create VPC. Leave it blank. The other things can be defaults. So just only fill the cluster name for ECS cluster. So the ECS cluster got created successfully. So right now it is like just bare bones. There is nothing really there other than a definition of a cluster name. There is nothing really running, no task or services running. So let's go back to the workshop steps. We created a cluster of networking type that is for Fargate. We created that. That's great. Now we are going to create a new service, and the service name is in step 2.1e backend legacy service. So go back to ECS cluster. We are already in the cluster we created. We are going to click create under the services tab. Click create. The launch type is Fargate. It is of type Linux. It already has pre-filled the task definition for us. We had only one task definition, so it started pulling that. And for the service name, provide it as backend legacy service. And the number of tasks will be 1. Leave the rest as default. So what I'm doing is creating a ECS service definition of launch type Fargate. It would automatically fill in the task definition we created earlier. And the cluster is backend legacy cluster. Provide the service name as backend legacy service. And the number of tasks as 1. Leave the rest to be the defaults. Click on next step. And in terms of the VPC, it would show 2 VPCs. Pick the one that is having a CIDR block of 10.0.0.0. And you can also see whether this VPC ID matches with what we actually had in the CloudFormation template, VPC 0345. Let's see, 0345. So that is the VPC we should select. Remember, in the ECS cluster creation, we didn't choose create a cluster, so we are using an existing cluster, existing VPC. And in terms of subnet, select both the subnets that are available under this VPC with the CIDR block 10.0.0.0. The others are defaults, public autos in the public IP and things. So for the test setup, this is purely for like a crash and burn kind of thing. So we are going with node load balancers. In the actual production setup, you would be going with your own application load balancer. So this is just a dummy, like a mock-up setup. This is not supposed to be used for production. So click next. So before that, again, make sure you are selecting the VPC that is having the CIDR block of 10.0.0. And the VPC ID would match what is in the CloudFormation template as well as in the master map text file. Then select both the subnets, leave the others default, and we are just going with node load balancer because this is just a mock setup. And click next step, and finally click create service. So you should start seeing all green in terms of inbound roles, create service, security groups. So click on view service. You will start seeing the status as provisioning. So it is right now running. One of the steps that is yet to be implemented is letting this Fargate container image be able to talk to RDS. RDS actually has its own security group. So we need to open up the security group to allow the Fargate container to talk to RDS instance. So click on the details. You would see security groups. So click on that. It would open up a new tab that takes you to the VPC and security groups page. So let's look at the security group. So if you go back to the ECS, so the security group name is this, SG0834. So we do have it backend 5275. Now look for the security group that is relating to the RDS one. So is there a security group? Yes, there is a DB security group. So that is the one for RDS that allows specific users or specific resources to access the database. So if you click on, go and select the DB security group and click on its inbound rules. So the way you navigate is either you can open the console, go to VPC and then security groups on the left, or you can directly click on the ECS service. There will be the security group highlighted. Click on it. That should also take you back to this VPC management console page for security groups. And once you're there, click on the DB security group. Following that, go into the inbound rules. It basically shows there is a rule to allow MySQL access on port 3306 from one security group. This security group belongs to the EC2 instance for the Monolith. Now we are going to edit the inbound rules to allow, in addition to this, allow the Fargate to talk to the RDS instance. So the type would be MySQL Aurora. The ports are all pre-filled for you. And in terms of the source, try to copy and paste the security group that would be associated with your Fargate. So most probably it might be ending up with like a backend something. So select that and click Save Rules. So now we have edited the security group for the RDS instance to allow communication from either the EC2 or from Fargate related security groups. So security groups allow you to say like these resources need to be bundled together and they will have these particular allow rules. And they would be allowed to access this resource or the other resource. So that way it's a bit of a grouping as well as to allow inbound, outbound rules. So now we are done with that. Go back to ECS and let's look at the ECS service tasks. So it shows it as running, the task definition. And let's click on this task details. So it shows the public IP is 3.88. It would be a different IP for your own instance. So let me try to go there and type unicorns. And I access it. It is still trying to connect. Okay, yes. So my Fargate instance is able to actually serve the previous functionality from the Monolith. So the Docker container that is running the Monolith application is being served through Fargate on a given public IP address. So what I did was I went back to ECS service, and in the cluster there is a service. When I click on the service, I can look at the tasks. And when I click on the task details, I would be able to get its public IP. So basically, I access the public IP / unicorns. So now I'm able to actually see that that particular container is serving traffic on port 80 and providing me the set of unicorns. So once this is achieved, I can go back to the API gateway and I can go and edit the get to start serving. Instead of the EC2 instance, I will edit it to serve from the Fargate. In the production instance, it would be more like a load balancer endpoint rather than a simple IP. So now I'm done. Let's go back to method execution. Let's test it. So yes, it is able to invoke the instance now running on Fargate rather than running on EC2. So in terms of the functionality, we started off first with everything running on one monolith application on EC2. We changed it to run some partial functionality for the basket running on Lambda microservices. And then we replaced the monolith application with the container image running on ECS. Now that we have got that, we can also go in and actually edit the rest of the API gateway methods for the user and login to go to Fargate rather than going to the HTTP endpoint. So I can go in and edit it. This whole thing happens even as the underlying, even as the front end is totally unaware that the implementation has shifted from a EC2 to a Lambda or to a container image. Once the changes have been done, I need to actually go in and re-enable the chords. Any issues? So the workshop lab materials are available publicly, so it won't be removed or anything. So people can run it on their own accounts. The lab accounts would be open for another 18 hours and then would be terminated. So you can actually bookmark the workshop lab link for people who want to follow it by themselves.
Yeah, highly advise people to go through, spend some time in here, walk through some of those modules that maybe they kind of flew through earlier and understand the ins and outs and the technical pieces of it. But Saba, unless you have any last pieces, we can switch over so we can do our AWS survey.
Yep, thank you.
Excellent. Thank you, Saba. All right. So that brings us to the AWS feedback survey. We need to know how everything went today. And just as a reminder, because we do have a lot of presenters, Ramesh Chittarala, he gave us our overview and an initial presentation on serverless containers. Alan Litz walked us through lab modules 1 and 2. Todd Schaefer discussed agility by adopting the startup mindset. And finally, Saba Parmeshwaran went through module 3 and 4. And so as you'll see on your screen now, a pop-up will give you access to a very short and quick survey, but any feedback would be fantastic. If you enjoyed one piece versus the other, or would love to see content in the future for a certain piece, all that is very welcomed and appreciated for our team. So if you can just take one moment to go ahead and review how the workshop went, that will mean quite a lot to us. While you're doing that, just a reminder that should you have any additional questions, please go ahead and pose them in the chat. I'm going to go ahead and fire out a few questions to our support team that we noticed both in chat as well as in discussing the workshop ahead of time. So to begin, why should customers think about modernization with containers and serverless? Ramesh, I believe that goes to you.
Sure. Thanks, Jay. So basically, the gist of today's entire session was how important modernization is for increasing the business elasticity, agility, and if customers can modernize applications, the primary goal is to improve their return on investment, reduce total cost, and increase the efficiency of developers. So what we have noticed is refactoring to a modern architecture and adopting managed containers or serverless services helps customers better utilize infrastructure resources, reducing TCO by 60% over a 5-year period, according to the IDC survey that we saw. And for example, technologies like AWS Lambda and AWS Fargate, they help customers scale based on the fluctuating needs of the workload automatically. So these are some strong reasons why we would encourage customers to consider containers and serverless for their modernization journeys.
Excellent. And then if I'm building a new application from scratch on AWS, what is the recommended modernization approach for me?
Absolutely. So sometimes the easiest path is greenfield application development, where you're building the full application from scratch. If that's the case, then we would recommend a serverless approach because it delivers maximum business value and the most velocity to the business. And if customers prefer open source compatible solutions, then that's when we would recommend you start exploring the container services we have, EKS or ECS. But those would be the broad guidelines to start with.
And then I noticed this throughout the chat. Can someone explain the differences between ECS and EKS and when I would most likely want to use one versus the other?
So this is Steven. Jay, I'll take that. So ECS and EKS are both very good orchestration platforms. They can do quite a bit for you. The dynamic tends to break down from ease of use or versus control over the details of the implementation. I'd say ECS, you can get up and running. You can get a lot of things going. If you're just trying to get that job done, ECS is a good platform for you. EKS is kind of the industry standard. The Kubernetes is industry standard, kind of a container orchestration platform, and it has the best access and most integration with open source projects. So if you really want to get kind of the latest and greatest coming out of the community, and you want to dive deep into various technical aspects of the container orchestration, that tends to be the way that you would go. They both can serve very large corporations, workloads. So the size of your workload or the amount of containers you need to run isn't really a deciding point. It really does seem to break down to ease of use versus fine-grained control.
Excellent. And then what about Amazon EMR on EKS or EC2?
Yeah, so that would be so EMR is our big data platform. So it allows you to run things like Spark and get your Spark jobs done. It's used for data processing, orchestration flows. So if you're having a workflow where you have Spark jobs, and they need to come up and come down, they're kind of spiky, and you find yourself sitting with an EMR cluster or set of servers or virtual machines that are sitting around. They're not being used quite as effectively as you'd like. Running on EKS can be a great way to allow you to kind of spin that up, run the jobs you need to do, and then spin it down so you don't have to pay for it. EMR gives you a lot of flexibility. EKS gives you a lot of flexibility in running your EMR that way. If you found that you had an EMR cluster that was running consistently with kind of a level set of compute and utilization over a long period of time, you probably would want to just go and stick with EC2. You're not going to get that much advantage, and you will put in a little extra work to get the EMR running on EKS.
Excellent. And I think this one's going to come back to you, Ramesh. I'm already running containers on-prem. What is the recommended modernization approach for me? Ramesh, did we lose you there?
Sorry, I think I didn't unmute myself. Can you hear me now?
Yes, we can hear you now.
Sorry. All right. Yeah. So if you're already using containers, running containers on-prem, then you're already one step ahead. Containers are an easy and portable way to run and deploy applications. And whether you're running them on-prem or in the cloud and self-managing them, you would greatly benefit from migrating them to the managed services that we have, like EKS or ECS, and also Fargate, to reduce the operational burden and gain the benefits of scalability, reliability, security, and availability. And that's because AWS does the heavy lifting for you for the provisioning the infrastructure and container orchestration, and it would result in simplified operations, and you can reduce the management overhead. So that's kind of a low-hanging fruit opportunity for you if you're already running containers and you want to quickly move workloads to AWS.
And then we're a little tight on time, but one last question here. Instead of use of the API gateway to the public IP of the ECS Fargate, can we set up a name instead in static IP? Sorry, Richard or Ricardo, I did my best to try to do that, but it's the most recent question there in the chat.
I can answer that. This is Sabah here. So the API gateway is the entry point for the UI to talk to the backend, right? So we already configured the front-end UI application. It's config.json to talk to API gateway. API gateway allows you to mediate the calls going to the backend. It allows you to massage the payloads, put in throttling, put in API keys or authorization and authentication. But what API gateway in turn talks to can be a ELB, it can be a HTTP endpoint, it can be a Fargate instance. So in your Ricardo's case, I don't know, like the Fargate can be an IP, it can be a load balancer too.
All right. Well, we're up against the clock at this point.
Route 53.
Yeah, we're up against the clock at this point. But should you have any additional questions, please feel free to schedule a consult with our team by simply using the pop-up on your screen. That'll be flying up any second now. Again, special thanks to Ramesh, Alan, Todd, Saba, Robert, and the entire AWS team for their many hours of preparation. We'll be following up with a copy of today's presentation, as well as a link to the on-demand copy of the webinar, or workshop, rather. Within hopefully 24 hours. Sometimes it takes a little bit longer, so it might be Monday when you receive it. But otherwise, we hope everyone has a great rest of your week, and we certainly look forward to discussing serverless with you and AWS very soon. So thank you again for attending.